Hello, hello, hello. Hello, hello, hello. Good afternoon, good afternoon, good afternoon, everyone. Namaste, namaste, namaste. Hello, hello, hello. Good afternoon, good afternoon, good afternoon, everyone. Namaste, namaste, namaste. Can everyone hear my voice clearly? Please make the chat window a bit bigger. Yes. I think it's too big now. Yes. Yes, yes, yes. Good afternoon, good afternoon, good afternoon, everyone. So, how are you all doing? Quickly tell me if you all can hear my voice properly. Namaste, namaste, namaste. Jai Shri Krishna, Radhe, Radhe, Ram, Ram, everybody. Let's quickly start today's class. My name is Rajwan Singh and I welcome you all. This is lecture number 11 on electric charges and fields for the Target 2026 batch. Yes, come. Yes. So, brothers, today we have shifted to a new studio again. Alright, anyway, let's do a voice check over here again. First, everybody tell me, is the voice clear to you? Yes. Come. Yes. So, okay, your test has been done. Very good. So, how did the test go? Yes. Everybody tell me this also once. How was your test? Yes. Scores are coming in. That's great. Very good. Yes. Someone said there was cheating. Well, you could have done it too. Don't be too honest these days, brother. I'm telling you beforehand. Yes. The scores are looking very good right now. But my dear, don't do this. Don't give one test and never give another. This was just your first test, okay? We will set a target for the next test right now, okay? On Monday, I'll give you a target for the next test, specifying the topics it will cover. And if it is still here, then start preparing for it right away. Alright. Very good. Yes, that's excellent. For those who made mistakes, note them down. Firstly, those who did not give the test, just say sorry. Okay, and those who gave the test and made mistakes, mark them. No need to make a separate notebook. Just mark them somewhere in your notes only that I made mistakes in my test, so I will not repeat them. That I will again revise it properly. Understand? Is it clear? Yes? Okay. Very good. Alright, some question was out of syllabus also. Which one? See, I don't make the question paper, okay? Alright? But I'll have to notify them if that's the case. Just wait for a minute. Let me tell them once. Ma'am, today, please send me the short test that was conducted for today in Lakshya target batch. Because the kids are saying that some questions were out of syllabus. So please send it to me once. Okay. Let's find out. What is the matter? Let's find out. Okay? Let's go. So all of you have given the test. That's a good thing. Okay? Let's check which question it was. Okay? By the way, we'll rectify the syllabus issue and discuss it again with you tomorrow. After they send me the test. So did you watch the video I assigned to you yesterday? I was reading your comments. My goodness, you guys have so many doubts. Really? Wow. The list of documents I gave you, did everyone go through it? All the documents that you should be having with yourself. Have you seen that? Okay? Oh my god, different kind of doubts. I was just thinking, how are we going to solve these doubts? Some were pretty intense. Yes. I saw. Yes. Very good. In that, some kids had really weird kind of doubts. Sir, in the Aadhaar card photo, we have some hair over here and this and that. So will it be approved? Do you want to be slapped? Huh? Talking all this nonsense. Yes. Those who haven't seen it, my dear, please see it once. The list of documents, at least see the PDF. Okay? That what are all the required documents that we need to have prepared with us. Yes, there were also many genuine doubts as well in that. That's why please explain this in detail. Like some children asked about EWS certificate. Some children asked about, sir, what is the difference between state and central caste certificates? So that I will give you whenever next time I make it, okay? Yes? Okay? Yeah. Clear? Very good. Yeah. Some different, very weird, silly doubts as well. All those things. See, brother, if you have uploaded your photo in Aadhaar card 1 year ago, it is not possible that you have changed a lot all of a sudden. You still look like how you used to look in 10th class, okay? Still the same. You might have just got 5 more hair on your head. That's it, okay? All right. So if you feel like all of a sudden your smartness will decrease and JEE main people think, who is this guy? He's different. Look at him now, how smart he has gotten. He should be selected. My brother, you get selected according to the marks, okay? Not on the basis of your looks. But definitely your photo shouldn't be like that also, that they don't recognize you only. That they feel like you have definitely come to give somebody else's exam. Okay? Yes. So those small little hairs that you have gotten now on your cheeks, on your face, somebody gets it here, somebody gets it there. Okay, that's really not a big deal. Just cut them up, just trim your beard a bit and go. Okay. Yes. Yeah. Very good. Yes. So, although you won't need this, my dear, you all in the class, like today's lecture, will be on the advanced topics. Got it? Although you won't need it, but those who think they need it, they can definitely buy SKC. Okay? Yeah. But I think, according to me, we should focus more on what is being taught in the classroom. Magnetism and EMI for now. We should focus on that. Try to learn as much as possible from class notes. The concepts are almost the same, with slight differences here and there. Is that clear? Alright? Yes. Is it clear? Yes. So according to me, there is no need to take any pressure right now. The maximum that you can learn from the class, that is very important. So let's move on. I brought some advanced questions for you all today. Okay, so today we are going to, firstly, the target that we are going to set for today is, for the boards, my dear, see, right now, let the electric field finish, okay? Then you will get to compare what we are preparing here and in Catalyst, okay? There is a big difference between boards and this. When you prepare for boards, you feel like you need to study everything. No. Today's lecture is far from boards. Very far. Very far. So, try to understand as much as possible, okay? Okay? Is this clear? Yes? Yeah. Oh yes, the operation went well. Okay? Yeah. Operation went well. I had to visit the doctor in the morning also. That's why I shifted the class a bit. Because after the operation yesterday, there was a follow-up today. Okay? So the operation was good. Thank you so much for all of your wishes. I read your comments. Thank you so much, my dear. Okay? The first eye operation was done yesterday and the second one is scheduled for May 17th. Okay? So it will be at that time. Okay? Clear? Yes. Thank you so much, beta. Love you all. Love you all. Okay? So let's move ahead. Everyone will pay attention in today's class. Okay, one kid is asking about the duration of the class. We'll take it very easy with the questions. Monday's class will also be on advanced topics, discussing good questions. Meaning only good questions will be discussed in that class. That will be our aim. A lot of students tell me that I don't know 11th class well, I don't understand it, this and that. If somebody is very weak in terms of the concepts of class 11th and he's not even motivated enough, then I would just say, just skip this lecture. Don't watch this lecture. I'm not going to teach any theory today. I'm making it very clear, okay? I'm making it clear beforehand. All the kids keep this thing in mind that no theory will be taught today. No theory, only numerical analysis and questions, okay? If you know a bit of 11th grade stuff, even a bit if you know, okay? Even a bit, like if you know force equals MA, basic integration, and you are motivated to learn something new, then you will have to work hard. If you have motivation enough within you that if I have to learn something new, I will have to put efforts into it, then it will be okay. If things had been easy for everyone, then everybody would get selected, no? So, if you lie in this category, then you see today's class, you attend it properly, and if you don't lie in this category, then I would just say that let's skip this lecture and just go back and do your revision. Firstly, you have to give boards, then you have to give JEE, then you have to give advanced. So it's not like you only have to get demotivated. And later on, you demotivate me in the chat that, sir, I did not understand this, I did not understand that. And then on Monday, I think that I should make it a little easy for you. But those who are hardworking students, I'm just going to tell them that today, sit calmly and pay attention to me on the board. Is it clear? Yes? Very good. Anything, those kids who are saying, don't create a FOMO, okay? Like what if I miss something that stops my selection? No, it's not like that, okay? It's boards first, then JEE mains, then advanced. So today's class will be for the third step. If you think that your 11th is done well, and also you don't have to sleep here, okay? You have to keep sitting till the class goes on. You have to study. Is this clear? Yes? Okay, let's go. So, all the students, pay attention over here. Okay, let's do the question that we were left with previously, and then we will move on to the level up questions, okay? Okay, so let's go. Okay, first I'll give you a timeless poll. Start. Come on, everybody. Yes? See, my dear, for 12th class, I've told you already. Oh my God. Brightness is high. brightness is the least over here. Over here, the brightness is the least. Duration will be of 2 to 3 hours. We will study till 4 p.m. or maximum 4:30 p.m. I'll leave you all. Okay? Yes? See, you will have to do 12th along with your advanced. I know what you're struggling with. Usually the struggle is how do we manage boards along with advanced. 12th is not a struggle, my dear. Okay? 12th you will only be able to do by being regular over here. If you start finding shortcuts, then 12th will be finished. The load of 11th class, I've told you, leave it on me. And simultaneously with all this, you have to prepare for boards. That is your responsibility. So for class 12th, you have to do nothing else. If you take a lot of load, then you will keep sitting here. Take it easy, calmly. I am there with you. Okay? Yeah. What is he saying? Increase brightness. Okay. Is it fine now? Yeah. Yes? Increase. Okay. Okay, so let's go. I think now it must be visible to you. What is the question saying? A uniform electric field E is equals to 8m by E. What is this? 8m by E? What is m? Okay, let's see. Oh, it must be charged by mass for sure. Is created between two parallel plates of length 1 meter as shown in the figure. Okay. Where m is the mass of the electron and E is the charge of electron. An electron enters the field symmetrically. It is coming from between both of these two with a speed of 2 meters per second. Speed of 2 meters per second. The angle of deviation of the path of the electron. So we have to find out at what angle of deviation will it come to us when it exits the field. We will do it very calmly, very easily, okay? Okay? All the kids tell me one thing. That we have one plate over here. We're going to do this very calmly. We're not here to rush through the questions but to learn the concepts. It's not like we have to rush too fast and it'll be okay. We have to learn the concepts. The electric field given over here is downwards. Okay? Electric field over here is downwards. Now what you have done here, my dear students, you have taken an electron over here. Now you have thrown an electron here. Everyone gives a thumbs up. Will it go up? Why? Because whatever force will come upon this, whatever force will be on this, it will be in this direction. Why? Because it is exactly opposite to the electric field. Okay? Now we have a length of 1 meter over here. This is 1 meter and the speed over here is 2 meters per second. 2 meters per second. 2 meters per second. Acceleration along y, which will be QE upon m, where Q by m is given and electric field is given to be 8m upon E. 8m by E. Volt per meter. E cancels out. Okay. E. And this comes out to be 8 volt per meter. Okay. Standard unit. Volt per meter. Very good. Now you tell me one thing. They told us that all of you must be knowing already that this will go upwards. So this will keep going and then after going out, it is going out somewhere. Okay. So it will have a net velocity. Yes. All the kids tell me one thing. In the x-axis, will the velocity change or will it remain the same? Tell me this. Let's see if you can think. Sir, how will we find out the direction of force in the electric field? Samrat, my dear, your name is so grand, but your doubt is so useless. Oh, my dear, in any electric field, today's class will get very difficult. If you put a charge over here, force on the positive will be here and force on the negative will be here. How many times should we tell you this? Yeah, very good. Because we have no force on the x-axis. No force along x. No force along x-axis. Okay, that is why your acceleration comes out to be 0. Over here it was given to be 2 meters per second. It will remain the same. Yes, it will remain to be 2 meters per second over here. All the kids, very good. Now the game starts. Sir, this Vy we can find out. We have this over here. If we can find that out and we can find out the angle over here because tan theta is equals to perpendicular upon base. So over here tan theta that is equal to Vy divided by Vx. And we are already given with this so we can find out Vy. Now all the kids tell me this. Vy in how much time? In how much time will it come out from here? Because what will this acceleration do? This acceleration is increasing its speed in this direction. It is increasing it. So all the kids firstly think, what is the time taken to cross the plate? Time taken to cross plates, how much will it be? My dear, slowly attempt it. Even if you don't get the answer, you learn only if you fight. Very good. Very good. Sir, along the x-axis, it will go with 2 meters per second only. Y-axis, its speed will increase because acceleration comes in. Very good. So can I say this, that Sx is equals to uxt plus half axt square? Yes, sir. There is no acceleration in the x-axis. I said yes. Absolutely. Sir, when it would have gone for 1 meter, so we have the speed which is 2 into t. So times value comes out to be 1 by 2. That means in 0.5 seconds it will cross the plates. It will cross the plates. Cross plates. Now it's done. So sir, in the similar time, how much would our velocity become on y-axis? So Vy is equals to, my dear, uy plus ay into t. Yes. And what was uy? Very good. Love you, my dear. You have to fight like this only. Sir, along with the y-axis, there is no velocity. Because whatever you have thrown it horizontally. I said yes. So if you have thrown it like that, then uy comes out to be 0. And ux is equals to 2. So I said, uy we have is 0. Uy we have is 0. So this becomes 8 into 0.5, that is 4 meters per second. Very good. Very good. One kid says that, sir, I've used the third equation. In the third equation, v square minus us is equals to 2as. So, how did you find this height over here? How did you find out that the height we have over here is how much? Third equation you won't be able to apply. In the y-axis, how much did it run? How would you know that? Tell me. Yes? Either you say s equals to ut plus half at square. First I'll calculate Vy, how much it went, and then I'll apply v square minus u square equals to 2as. Then it will work. Okay, that's done. So we got the value of Vy here as 4 and the value of Vx was 2. So this gives us 2. So from here, sir, theta is equals to tan inverse of 2. That is your answer. Is it clear, all students? That is your answer. So what option are we getting? Theta equals to tan inverse of 2, B option. That is going to be your answer. Very good. Love you. Very good. Very good. Sir, why is gravity not taken? Until and unless. Remember, my boy, why should I keep repeating this? Until and unless G is mentioned. G is mentioned. Unless it's mentioned, okay? We will only take electric field force. Because this gravitational force, my boy, is very small in comparison to that. So you can neglect the gravitational force, okay? But sir, you took it in previous question. So when I mention it, then you have to take it, otherwise not. Okay? Yes? Yeah. Sir, how did volt per meter come about, my boy? The electric field we have for you is force per coulomb, okay? Force per coulomb. Meaning F by Q. It has another definition. Another definition we have is, which will be used in the next chapter, okay? Electric field is delta V divided by delta R. This is voltage and this is your distance. Simple. So for now, see, it has another unit as well, volt per meter. You can write that too over here. There is another unit of it, volt per meter. You can use that as well. Oh my God, my boy. I'll tell some students to leave the class, brother. Today it will be too painful for you and for me. One is saying Q by E. Why did you take Q as E? Oh my God. Oh Lord. First doubt. I feel I'll only be able to do 4 or 5 questions today. Sir, why is it volt per meter? This is another unit. This is another unit of electric field. Oh Lord, I'll have to close your chat, okay? If you have any more doubts beyond this, that means it's useless. Don't watch this lecture because the questions that are coming up will scare the living daylights out of you. Your time will be wasted, you'll just curse me, demotivate, and it will impact the next class. So go and read some basics from your old 11th grade syllabus, okay? That will be much better for you. Oh brother, you picked up a ball and threw it straight. So will there be any velocity along the y-axis? Having to explain this is so painful. Today's class was a bit advanced, but this is also a pain now. When you read this question symmetrically between the plates with this, it was thrown in the horizontal direction. So the velocity along the y-axis will be 0, right? Along the x-axis, it was 2 meters per second. Is any force acting in this direction? Just now one asked, sir, how did you determine the force? Brother, I explained this in the last class. You were supposed to revise. I gave you a target till Friday so you would cover your backlog and today's class would be fun. But you ruined the mood right at the start. In any electric field, if you place a positive charge, the force will act this way, and if you place a negative charge, the force will act that way. If the electric field is constant, charge is constant, then the force is constant. Divide by mass and you will get the constant acceleration. F equals to ma. Is there any force along x-axis? No. So what will our ax be? Sir, ax should be equal to 0 because there is no force there at all. No force at all. Sir, there will be force along y-axis? Yes. If the electric field is downward and you throw a negative charge, the force will act upward? Yes. So what will be the acceleration? Sir, it will be in the upward direction. How much? QE by m. What does Q mean? It's the charge. Okay, so we took E by m. You can take the charge of an electron as E and the electric field was 8m by E. This and that cancels out and we get 8 volts per meter, or you can say Newton per coulomb. Okay, it is just the same thing. Okay, both of them are same only. Now the point is, when it's moving in this direction, there is no force, so it will keep moving at 2 meters per second. But what will the electric field do? It will lift it upward. So, along the x-axis, it stays at 2, just like in a horizontal projectile. Along the y-axis, the velocity will change. So, in how much time will it cross this? Sir, when it has travelled 1 meter with a speed of 2 meters per second, it will cross. So, the time comes to be 0.5 seconds, yes. And in these 0.5 seconds, what velocity has it gained, sir? That is v equals u plus at. And based on that, we calculated the velocity. Now, what is the angle of deflection? How did you throw it? And it's still going on. So how much angle has it rotated? Sir, we needed this theta. It was shown in the question 2. So we applied tan theta here. Is that clear? This doubt could be of our idiot students. So listen carefully to avoid this mistake in the exam later. Okay? So listen to me carefully. Okay? Other than this, if you get any doubt, then just consider it to be useless. It's only stopping you from getting a rank in IIT. Okay? You're just creating a doubt for no reason, thinking that since other students are also asking something, maybe I should also ask. I'll seem smart. You will look like a fool, okay? Now understand. You threw a charge from here, okay? The electric field was like this. So you also know, sir, that it will move in a parabolic path. It will go something like this. This is a parabolic path. We know this? Yes, sir. Some students say, sir, let's do it this way. We have this distance Sx, which is equal to 1 meter. So, sir, let's calculate Sy. Some students might have done this. Sir, Sy equals to uyt plus half ayt square. I said, okay. So, sir, uy is 0. I said, yes. So, sir, half ay was, we had 8 into time, which was 1 by, what did we have? 1 by 2, right? 1 by 2. So, sir, this becomes 1 by 4. So, this becomes 2 and this becomes 1. Meaning, the charged particle, now listen to me very carefully. According to these students, what happens is, sir, this is 2 meters. This was 1 meter. Yes. Okay. This was, and our particle went somewhere like this. So, we needed this angle. We needed this angle. So, sir, if we look vertically, this angle is theta. And then this angle is here. Now, you've done all this drama. It is all worthless. It's a worthless drama. This is just worthless drama. Those going by displacement, brother, is this a straight line? It's not a straight line. It's a parabolic path. That's the first thing I told you. And the second thing, pay close attention to this. Angle of deflection. Listen carefully. If you need to find the angle of deflection, write it down in your notebook, okay? Always from velocity. Always from velocity components. Always calculate it from the velocity components. Why? Some students say, sir, remove this. I said, okay, I've removed it. Sir, the net displacement is this. Look from here. Sir, the net displacement is this. So why not I calculate the angle from the net displacement, sir? Angle. Oh, you idiot. The particle will move like this and go like that. Got it? What's the direction of your displacement? The direction of your displacement is this. Okay? What's horizontal? The particle is moving like this. And you needed to find this angle because this is how much it deflected. It was going here first, okay? It went here, going, and became like this. So you needed this angle. And which angle are you calculating? You're calculating this angle. The student who calculates it from displacement will get the wrong answer. Do you understand this? Yes or no? Now tell me. Yes or no? Tell me now. This mistake can happen in the exam from you. Sir, I calculated Sx, I calculated Sy, and then I'll find tan theta from here. So, sir, why won't the answer come from that? Oh, understand the angle of deflection. You were going this way. Now you have bent. So your velocity was this way. Now it's that way. So you need to find the bend in velocities, not the displacement. So we had this initial direction and velocity. Now we have this velocity. So we have the final net velocity and the initial net velocity. And we need to find the angle between them, not the displacement's angle. Understand? Listen to me, if it was going straight along a straight line, then the velocity would also be along that line. So whether you calculate from displacement or velocity, the answer would be the same. All students now make a heart, okay? Any other doubt is a worthless doubt, and even more worthless doubts. Is that clear? Yes? Sir, I didn't understand 8m by a. Then leave the class. Today's class is not for you. Yes? Sir, how did you get 1 by 4? Oh my God. Son, I'll give you the recorded lecture. Got it? I'll give you the recorded advanced one. Then keep fighting and arguing with it. If you are having doubts at this level, okay, let's go. Next question. We have, what is it saying? This is also a JEE mains question. Don't get it wrong, okay? Okay? Son, my boy, leave the class because I'm telling you honestly, after this next question, you'll start crying. 2-point charges A and B of magnitude 8 and this are respectively placed at distance d apart. There are two charges, my boy, plus 8, and how much is this given? Plus 8 into 10 to the power minus 6 coulomb. They could have called this micro as well. Keep that in mind. And the second one that we have, another charge, my boy, that is minus 8 into 10 to the power minus 6 coulomb. Okay? Okay. Respectively placed at distance d apart. Placed at distance d. The electric field at midpoint. The value of electric field at the midpoint. At the midpoint, we have the value which is your E is given. That is 6.4 into 10 to the power 4 Newton per coulomb. The distance d between the charges. How do we do this? Now two charges are given. Find the electric field at the point between them. Sir, it should be 0. Should I slap you? One is positive and one is negative. There won't be a null point. Okay, there is no null point for this. The electric field won't be 0 anywhere. So understand this, okay? If you assume this as Q charge, so the electric field due to this will be, sir, KQ divided by D by 2 square. And due to the negative 1, sir, it will also be in the same direction. I said yes, sir. So it will be KQ divided by D by 2 square. So add the net electric field of both. Yes. So E net will come. What is twice of KQ divided by D square by 4? Every step needs to be written because we have, oh my God, I'm scared about this now. How will this go? This 4 will go up, my boy. 8KQ divided by D square. That is given as 6.4 into 10 to the power 4 into 10 to the power 4. You have been given with all the values. 6.4 into 10 to the power 4 is equals to 8 into, what is the value of K? 9 into 10 to the power 9 into charge is 8 into 10 to the power minus 6 divided by D square. All the students who did this, give me a thumbs up. All the students, thumbs up who have done this. Sir, we calculated the electric field of both and the resultant value of the electric field of both is this. So, double it or add both individually. We will get this. we will get this. Okay. So what did we get? 8, 8, 64. And this becomes 10 to the power minus 1. Okay. So if you talk about d square, what do we get? 9 into 10 to the power 9 and 6 and 3 remains here. And this is 10 to the power 3 remains here. So it will be 3. So option A is your answer here. Yes? Very good. So option A is your answer here. Very good. Dear, if you write slowly, the question will be solved. Write slowly and the question will be solved. Okay. That's why I want us to practice questions with full focus for 2 to 2.5 hours. Physics is the same. It feels the same. It's just mathematically we're facing problems in the problem. Okay. Now understand uniform electric field. Listen carefully. The thing is, as soon as they see the data, half of the students' hands start trembling, man. Like, how is this given? What is Newton per Coulomb? It is the unit. And we have minus y cap. The electric field is in the downward direction. This is applied in a region, a charged particle with mass m carrying a positive charge. We have a positive charge, okay? Positive charge. This was asked in the multiple correct in JEE Advanced, okay? Now projectile motion and electric field, electrostatics, it's a combination of both, okay? This is projected in this region with the initial speed. How much is it given to you? We'll have to make everything from the data on the next page, meters per second. The particle is to hit target T. It wants to hit some target T, which is 5 meters away from its entry point in the field, as shown in the direction given. What is the value of Q by E given? Charge by mass, Coulomb per kg. 10 to the power 10. Now it says the particle will hit T if projected at an angle of 45 degrees. Hit it at 30 degrees or 60 degrees. It will hit. And how much time will it take? Okay, let's go. All students, look at this slowly. Okay, we have an electric field downward. I'm making a simple diagram. Here, you threw a charged particle. Sir, should I take gravity? Is gravity mentioned anywhere? No. So you won't take it, okay? So we have a positive charge. Yes, sir. You threw it from here. We have target T over here, okay? Whose distance is given as 5 meters. It's at this distance, okay? This is it. We have an electric field in the downward direction. The value of electric field is 400 root 3, okay? The ratio of charge by mass is given to us as 10 to the power 10. All in standard units, okay? And the speed given to us is 2 root 10, 10 to the power 6. 2 root 10 into 10 to the power 6. All students now look. Yes. Now look. The first option in multiple correct needs to be done with a lot of patience. The particle will hit T if projected at an angle of 45 degrees from the horizontal. They are saying if you throw it at 45 degrees, it will hit it. All students tell me, does this seem correct to you? Now, sir, what's the concept here? The concept is projectile motion. If we have a positive charge, the electric field is this way. So what force will act, sir? QE. So acceleration along y will be QE by m. I said okay. So the value of AY is coming to be, I can write it to be Q by m into E, right? I said yes, very correct. So Q by m is given to us, sir, 10 to the power 10. And the value of electric field is given to us as 400 root 3. So what will this be, my boy? 4 root 3 into 10 to the power 12. Is your option A coming? Very good. Love you, my boy. So this came, sir. I said, man, it's 1 theta when it's equal to 45 degrees. Then they are saying it will fall like this. So I said, okay, the range formula was u squared sine 2 theta divided by g. Instead of g, we will use acceleration along y. We will call it g effective, okay? Let's check the range. If you square u, this will be 2 root 2, 2 root 10, 2 root 10 into 10 to the power 6 square into sine of twice of 45 degrees, sine 90 is 1, okay? Divided by, if you talk about AY, 4 root 3 into 10 to the power 12 remains. So what's the range? If you square it, 4 into 10 to the power 12. Sine 90 is 1 divided by 4 root 3 into 10 to the power 12. Okay, so what do we get? This cancels out, this cancels out. So 10 by root 3 is coming, which is not equal to 5 meters. So it won't hit. It will not hit. Very good. Very good. Sir, not 45 degrees. Oh, it says the particle will hit the target if projected at 45 degrees from the horizontal. So I said, okay, if I throw it at 45 degrees, understand my approach. If I throw it at 45 degrees, then what's the range coming out to be? Is it 5 meters? If it was, it would hit. Okay, sir. Sir, we had the value of E, which was 40 root 3. Oh my God. Man, please don't attend the class, yaar. What a foolish person you are. I'm folding my hands in front of you, brother. Don't attend the class. In any vector, what's the sign in front of a vector? It's the direction. It shows the minus direction. The value is 400 root 3. That's what's written. Yes? So, what they said is wrong. If you throw it at 45 degrees, the range is not 5 meters. Clear? Sir, why didn't they take G? Don't even listen. Don't even listen, my boy. I'm the fool for coming here. What did I say? Is G given anywhere? Unless G is mentioned, don't take it. Write it in your notebook, okay? Everyone's saying chat off, chat off. Arjuna students would be knowing. I want to do it live in JEE advanced classes so that we can have some healthy discussion. One-sided information is written in books too. Then what's my purpose? My purpose is that I initiate a thought process in your mind. Sir, what's this minus? What's that? What's this? Don't attend the class, brother. I'm folding my hands in front of you. Don't attend. So at 45 degrees, what did we do? We calculated the range. Did the range come to 5 meters? It didn't. So I said it won't hit. It will not hit if the angle of projection is 45 degrees. What's this? The particle will hit target T. It will hit T if projected either at 30 degrees or 60 degrees. So I said, let's check. Okay. If we assume the angle of projection is 30 degrees, all students, take a look. If theta is equals to 30 degrees, let's see what the range is. If the range comes to be 5 meters, then it will hit. So, the range formula is, sir, u square sine 2 theta divided by acceleration along y. So, my boy, if you square u, if you square this, it will come to 4 into 10 to the power 6 square. So, 10 to the power 12. It's not 10 to the power 36. Some fools might think that too. So, sine of 60 divided by acceleration along y. What's that, my boy? 4 root 3 into 10 to the power 12. Okay. So, let's see what all cancels out. 4 and 4 cancels out. We have 10 to the power 12 and 10 to the power 12 will cancel out. Sine 60 is root 3 by 2. So, if you solve this, it will come to be 10 into root 3 divided by 2 upon root 3. This cancels out. So, this comes to be 5 meters. Absolutely correct. If the value of theta is 30 degrees, the range value is 5 meters. So, that statement is absolutely correct. Very good. Now, will it happen at 60 degrees too? Now, a very small concept from class 11th. Those who cry will keep on crying, my boy. Selection doesn't happen like that. Okay? If we have the angle of projection or complementary angles, remember, those who remember, what are complementary angles? On complementary angles. Whether it's theta or 90 minus theta, the range was the same. So, we have theta values of 30 degrees and 60 degrees. Both will have the same range. So, you didn't even need to prove 60 degrees if you applied this. Very good. At complementary angles, our range is the same. Okay. So, does this option, particle will hit T if projected either at angle 30 degrees or 60 degrees from horizontal? Yes? Clear. Time taken by the particle to hit. What will be our time? Those who are Arjunas, those who have put in even a little effort will apply the time formula. So, see, at which angle can it go, sir? It can go at these angles. So, I said, okay, time. We have t theta and t 90 minus theta. Those who remember, good. If not, I am explaining from the absolute basics that now we have figured out. Listen carefully. Now we have figured out that at theta 30 degrees it will hit. So time of flight is 2u sine theta divided by g. Instead of g, we will take acceleration along y. So 2 into what's the value of u, my boy? 2 root 10 into 10 to the power 6 into sine of 30 divided by, what's this? 4 root 3 into 10 to the power 12. Let's see now. Sine 30 and 2 cancels out. This becomes 2 for us. Okay. And if you see, I can write root 5 into root 2. Yes. Root 5 into root 2. Yes. Divided by 2 into root 3 into 10 to the power minus 6. So this and root 2 cancels out. So root 5 by 6 microseconds. Microseconds will be one time period. When you throw at 30 degrees, this will be the time period. Yes, very good. Love you, my boy. A lot of students are recalling. Okay, so I'm doing it from the absolute basics. Those who are Arjunas know that t theta divided by t 90 minus theta, that is equal to the ratio of tan theta. Okay, but if we do it from the basics, time taken by the particle to hit is this. And here it's also given root 5 by 3. This is just wrong for us now. Okay, this is just wrong. Sir, why would we get 2 time periods? Oh, 2 time periods will come because, my boy, listen carefully. When you throw at 30 degrees, the range will be the same. When you throw at 60 degrees, the range will still be the same. The range will be the same. But its time will be different and its time will be different. Clear? Our range will be the same, but time won't be the same. So here, t 90 minus theta, or when theta is equals to 60 degrees, then calculate the time period. So sir, 2u sine 60 divided by ay. I said yes. So 2 into uy, what do we have here? 2 root 10 into 10 to the power 6. 2 root 10 into 10 to the power 6 into sine of 60 divided by ay, that is equal to 4 root 3 into 10 to the power 12. Is that coming? Yes. Let's solve and see. Sine 60 is root 3 by 2. So this and this cancels out. Yes. And this will become micro. So I can write root of 10 divided by root of 3. Sine 60 is root 3 divided by 2. And this will be microseconds. So this and this cancels out. And this becomes root of 5 divided by 2 microseconds. Some students are saying, sir, how did we write this? Brother, write 2 as root 2 into root 2. Write root 10 as root 5 into root 2. 2 root 2 will cancel out and it will come to be root 5 by root 2. In microseconds. We have it in microseconds. This time is also correct. So B and C are our answers. Now see, 2 concepts. You'll mix 2 concepts here. Yes. This is your JEE Advanced. Yes. B and C, 2 options came. So it takes time, but if you see, you can make 1,000 excuses to get stressed and stop your preparation. Every year students do this. Students have to find reasons themselves that, man, sir explained all these things. I'm having trouble applying them. But if I practice a little, I can reach there. Yes? Clear? Now listen carefully here. Now all the questions that we have, these are all asked somewhere in JEE Advanced or can be asked. Okay? So listen very carefully. Now what did I do? I didn't bring a question. I want that your thought process get initiated first. We're not solving yet. We need to learn. So I've closed your chat. Listen carefully. E versus R graph. You'll get it in JEE Advanced 4 times. At least minimum. And the same approach you will get again in magnetism. Okay? The same approach you will get in magnetism. I'll tell you how far IIT has asked and what can be asked from it. Okay? Think very slowly. Understand the E versus R graph. What do these IIT folks say? They give a pair of 2 charges. Sir, we need to make this. First think. Okay? I'll give you time to make it. Then I'll take some doubts. Then you have to do the next questions, and I'll make a lot of modifications. Modifications matter in JEE advanced questions. Okay, and I'm telling all of you the same thing repeatedly. Write by hand. Class 11 got messed up, ruined, we'll fix it. In class 12th, your class 12 notes should be your own. Understand? Okay? And you were asking now we should do this or that. Nothing. Boards are separate. JEE Advanced and Mains, at least do it by hand. Otherwise, what will you learn? I have one charge here and one charge here. Listen to me very carefully. I am taking a very simple case, okay? This charge is plus Q and this charge is also plus. A very basic thing. What do we need to make? The electric field versus R graph. Okay? Try to understand this thing. First, what is it asking us? Draw E versus R graph. One question I will do and one question you will do. Okay? First learn here. Draw E versus R graph for charged pair. Charge pair. As we move along the horizontal line. As we move along horizontal. When we move along the horizontal line, then we have to tell the E versus R graph. So first we will see this. What did I do here? I kept two charges here. Okay? I kept two charges here. Electric field, we're going to remove the electric field lines, okay? Okay? Let's remove them for now and I'll make it in a grid. One charge is here and one charge is here. Okay, now how am I moving? Understand carefully. How will I move? I'll move along this horizontal line. See which one? I'm starting to move from here along this one. Understand this thing, and whatever value of electric field I get, I'll move along this line. Whatever I get, that only I have to plot in the graph. Okay? This is a JEE advanced question, asked 3 or 4 times recently. Now I'm moving from here, moving. Look at the electric field. Okay? The value is increasing. It's negative, but the value is increasing. It's negative, but the value is increasing, sir. The value is increasing, sir. The value has increased a lot, sir. But it is always negative, sir. Yes. Now, students, tell me. In this portion when I came, the electric field was negative. Very small. As I'm coming closer and closer, did you notice? It's becoming a very large value, sir. I said, yes. Yes, sir. And it's in negative. I said, yes. Why is it in negative? Why is it? Because, sir, we have come very close to this charge. So when the value of R is very small, electric field was KQ by R square. And the R is very small. So electric field will increase a lot. But in negative direction. We have to take care of two things. Negative is the direction, but the value is infinite. Why? Because the distance is very small. Very good. Now understand here a bit. If I close to it, all students can tell me the value of electric field here, right next to it. The value of R is almost 0. So, all students tell me what will be the electric field here in plus or minus, and will it be infinity or some value? If I'm right next to it, what should be the value here? What should be the value? Whoever gets this, their questions will start getting solved all at once. Yes. Think and tell what will be the value of electric field here. Sir, it will be infinite. Positive or negative? Electric field is a vector quantity, my boy. Positive or negative? Sir, it's repelling in the negative direction. It's also repelling. If you are very close to it, sir, infinity in the negative direction. Very good. Very good. Now, all students tell me what will it be here? Sir, if you come right next to it, what will it be? Because if you are very close to it, sir, it's still infinite. But we have here, the electric field is towards it. Okay, here it is towards it. So see, if you are so close to it that the electric field is so large, we'll have plus infinity direction. Plus infinity. Understanding this is very important. 4 points here we have, okay, here and here. Just catch these and your game is set. Then I said, okay, brother. Okay, now see. I'm moving along this line. Moving. We had a null point in between. Remember, electric field, sir, becomes zero. Where the force is zero, the electric field is zero. Simple thing. So I said that the electric field on this is on this way and this is on that way. And in the middle came a null point, okay? Now see, as I start going close to it, the electric field came in this direction, came, and this becomes very large for us, okay? Yes? This, sir, is in the negative direction, yes, and that is infinite. Same thing over here, it's in, sir, positive direction. In the positive direction and infinite. And sir, if you keep going in this direction, keep going, the value will keep decreasing and it will remain positive but will become zero. This is the whole process. Have you understood it? Please tell me. Now, how do we plot this graph? We are starting to move along this. As I get the electric field, I have to make its graph. This is a JEE advanced question, okay? So all students understand this process. We know, sir, my class 11th was weak. Sir, I studied this, studied that. Now, what am I teaching you? You're still not studying, my boy. Got it? You're still not respecting these words. That's why, because your level was bad earlier, you think this will get ruined. It will happen because you're not living in the present. You're in the past. You are a foolish person. At least think about what I'm explaining now. What class 11 thing did I tell you here? Tell me. If you come here, understand. What's the electric field here? All positive. Its electric field, sir, will come this way. This one's too this way in this direction. So, sir, both will add up. I said, sir, if you are very close to it, the electric field, sir, will be very large. So, sir, this is infinity in the negative direction. I said, okay. Sir, if you are standing here, I said, yes. So, sir, because of positive, it will be very large. I said, yes. Because of this positive, it will be this side, but it will be less. But the resultant will be on this side only. Right? This positive will be having a large value. If you look, because of this, sir, it's very large. Because of this positive, it's away. But this one is less. So where is the resultant? In this direction. So can I say that the electric field here will be in this direction? Resultant and plus infinity. Plus for what? Direction. And infinity means value. Sir, if you talk about this side, here your electric field will be very large in this direction. This one is this way, but if you are very close to it, it will result in the negative direction. Infinity and the same thing if we talk about up here, sir, plus direction, infinity, and at infinity the electric field becomes zero. Because you have gone too far away from the charge, it becomes zero. Now let's plot the graph. This is your E and this is your R. How are we getting the value of the electric field? When I was standing here at infinity. So what electric field did I get? Sir, zero. Okay. As I'm coming here, it will keep increasing in the negative direction. It will keep increasing in the negative direction. And this electric field will be, see how it will be? Like this. Like this. Sir, what did you do, sir? This is in negative. Value is negative. So, the electric field is coming negative and going towards infinity. Yes? So, we got minus here. Here the electric field is 0 and as you come closer to it, sir, it will go to negative. So, sir, it's negative and towards infinity. Okay? Okay, sir. Sir, how do we do this? So, here, this is the plus directions infinity and this is the negative directions infinity. As soon as you come here, the electric field value will be very large. And what do you get in between? You get a null point, my boy. So try to understand this. The electric field in the positive direction decreases and becomes 0 here. And then it converts to negative like this. Okay. Sir, what did you do? Oh brother, what's the electric field here? Minus infinity. And what does minus represent? Direction. So negative direction, infinity. Understand this, plus infinity. So this graph is from here and increases towards 0. Now tell me, how many students understood this? Sir, what graph are we making? If you stand here, what value will you get? Sir, very large. I said, okay. In which direction will you get it? Sir, in the positive direction. I said, if I make an E versus R graph here, where will you plot its value? Sir, very large and in the positive direction. I said, okay. All the students, just give me a thumbs up. I've forgotten to turn on the chat, but it's okay. Once, tell me, have you understood this approach of plotting the E versus R graph for two positive charge? Plus Q and plus Q was made. Okay, think once. Plus Q and plus Q. And JEE Advanced has asked this. We're not doing this out of nowhere. Suddenly in the exam you'll feel, yes man, yes, very good. It won't suddenly come to your mind. Now you'll learn today. I'll show you the same question in magnetism for JEE Advanced, okay? Alright. If you learn today, magnetism will feel easy. Let's learn a bit. Now, raise your hands on this. Okay? Now this is almost the same question for you. Question number 4. In this, I am just giving you an example now. Try to do it on your own. Think about it. Okay. Let's go. 2Q in positive. And over here I have, let's see who is able to make this. And over here we have Q in positive. So all the students try and make an E versus R graph. Make this one. And I'm giving you one more. We have plus Q and minus Q. All the students make an E versus R graph over here. Let's do it. Sir, this graph is of tan theta. I'll give you a tight slap. In the electric field formula, tan theta is coming. KQ by R square is coming. This is inversely proportional to R square's graph. All the students now try to make it. What did I say? All students will catch 4 points. Which ones? Look at this point, look at this point, look at this point, and look at this point. At infinity, the electric field that we have will be 0. Here too. And E at infinity will be equal to 0. Yes. Very good. The kids are catching it. All students first write this. Sir, if I'm standing here, its distance is very small. The electric field will be very large. I said in which direction? Sir, it will be in this direction. So, sir, this will be negative direction infinity. And sir, similarly, if you make it over here, sir, this will be infinity in the positive direction. Right? Try to understand this. Why did this come plus? So, sir, we came very close to it. So, its electric field is away. This one's also away. But this one will be much larger. So, the electric field, sir, will be in this direction. Sir, negative direction is infinite. And here we have positive direction infinite. Yes. Remember, you won't get a null point in between. When there are two like charges, the null point is somewhere shifted towards the smaller charge. Okay, null point is somewhere shifted towards the smaller charge. Towards the smaller charge. And if someone asks, how much was this x? You'll remember the value of x, d upon root of 2 plus 1. Very good. Sir, the E versus R graph of this, let me make it here only, okay? We have, what will be its E versus R graph? I said C. This is plus 2Q. And here, we also have plus Q. So, if I have to make the E versus R graph, now see. So, now look carefully. At infinity, it will be 0. As I came towards it, the electric field will be negative and going towards infinity. So, somewhere this graph will look somewhat like this. Okay, this graph will somewhat be making like this. Towards 0 at infinity, and as you go close to it, it will shoot to minus infinity. Yes? As soon as you come to the charge, sir, plus infinity. So, where's plus infinity? It's here. Now, what some students make? They make the graph like this. Sir, here minus infinity. They make it somewhat like this. It will not be like this. It won't ever be like this. The null point will come close to it, my boy. So, from the options, what will you have to select? Sir, from the options, we will have to select a graph that will be a shifted one like this. Okay? And it started from plus infinity and goes towards 0. Sir, here is our graph. Who all matched it? Make a heart. Who all matched it? Please make a heart. Come on. Yes? Who all matched it? Make a heart. Right? Let's go. To the next case. All students, case B. You guys will make it. First analyze, my boy. See in JEE advanced questions. Now this JEE advanced questions, are you applying any formula? It's all a mind game. Now those rote learners, sir, I memorized the formula and sat. I can't solve questions, sir, because you have to think too. And if you don't practice like that, it will never happen. Listen carefully. Here I'm taking plus Q. And here I'm taking minus Q. Listen carefully. One positive, equal and opposite. Remember, no null point comes. Okay? No null point will come. It's E versus R graph. Draw E versus R graph. Make E versus R graph. Come on, brother. Let's see how many students are able to make it. Draw E versus R graph. Let's go. And I'll take one more over here. Make it, make it, make it. It should match, brother. The E versus R graph of this. Let's go. If you move the pen slowly, only then you will learn, brother. I can't teach crybaby students. Because you don't have the will. Remember when class 11 ended? You were crying that I made a mistake. The mistake wasn't because you didn't study. The mistake was because you didn't have the will. And class 12th is here now. Sir, I'll just get started. I'll blow it away. I'll do this. I'll do that. It doesn't happen like that, my boy. You have to grind the pen. You have to cry every time. Now you make this E versus R graph of it. What did I say? If you catch 3 or 4 points, things will come on their own. In this, there will be no null point. No null point exists at all. So you won't see the electric field 0 anywhere. If we talk about this point, sir, positive will be very large. Like this and like this. I said yes. So, sir, this is infinite in the negative direction. This is infinite in the positive direction. I said exactly. Sir, because of the negative, the electric field is towards this. So, sir, what's the direction? Some students say, sir, this is a negative. Oh, I'll slap you hard. What's the direction, sir? So, the direction is positive. So, sir, it's infinite in the positive direction and infinite in the negative direction. Is that clear? You will get the options, some here, some there, and you'll keep searching. Understand this thing, my boy. Some students are saying, sir, this should be negative. Look at the direction. This is a vector. Oh my God. How is this vector negative, my boy? It's in the positive direction. Its value will be infinite because the distance is very small. Is that clear? All students. Is that clear? Yes. Now how do we make the graph? At infinity it's 0 and here, sir, it will go to minus infinity. So here it is. Sir, here it is plus infinity. Then some students say, sir, plus infinity and this will be the graph. You made the electric field 0 here. The electric field will not be equal to 0. It will start from plus infinity. It will go exactly to plus infinity like this. Something like this. Some students will say, sir, this is parabola. I'll slap you. It won't come as a parabola from anywhere. You don't call it an equation by looking at the curve, my boy. Second thing, sir, here it is minus infinity and then at infinity it goes to 0. This will be the graph. Those students who touch this point here, the answer is wrong. You're saying the electric field is coming out to be 0. There won't be any null point in positive and negative here. Who all have matched this? Yes? This came in JEE Advanced. Whoever gets this right for real, it'll be fun. This, I said, came multiple times in the JEE Advanced. So this came twice in JEE Advanced. Advanced into 2 times. Whoever made this graph, understand. So much of your JEE Advanced analysis was successful. Come on, brother. Do it. Matched? Let's see it now. I'll show it simulation also once. All students make this. There is one plus Q and there is 1 minus 4q at distance d apart. Where do we have to move? We have to move on the x-axis. As I get the electric field value, I'll keep putting points on the graph. Basically, that's what we have to do. Those students who have doubts about this, I'll show you with a simulation, okay? All students pay attention here. There was one positive charge and one negative charge, okay? Okay? Here is my sensor. Understand carefully. If I am at infinity here, in which direction is it coming from, sir? It's going to be in the negative direction. And as I'm coming closer to it, coming closer and closer, what's the value, sir? It's becoming large, minus infinity, sir. Now see, when I come here, it is plus infinity, sir. It will decrease. Sir, this will become 0. No. Now see, this has again started increasing. It didn't decrease anywhere. Here it was very large. So that means the graph is upwards, okay? And as you went further, the value kept decreasing. A minimum came in between. What came for you? See here, the value is very large. Came, and this made your minimum value. And then it started increasing again. Then here, we already have the graph. So, what does this graph represent? Here, the value will be very huge. As you come further, the value will decrease. A minimum will come, then the value will again increase. So this type of graph will come for us. Clear? It's done? Yes. Very good. That's the thing. Some students have made the graph well. The first thing, there was supposed to be a null point over here. Some students did not even notice. Now, where will the null point be? Tell me. Some students forget that there was supposed to be a null point in this. Yes, sir. And sir, where is the null point always? Towards the smaller charge. Now see, you don't remember force, okay? That's why I said if we revise force well, then only we can build here. Remember? Towards the smaller charge, outside the line joining. Whichever line of charges are there outside it. Some students think the null point will be here. Not here, my boy, whose magnitude is smaller. So the null point won't come here. It will come somewhere here. It will come here. Very good. Some students say, sir, why minus 4? Sir, this is smaller. I'll slap you. Magnitude is considered. Okay? Now, sir, how do we make the graph? I said, come on, what will happen here, sir? Positive direction, and this is negative direction, infinity. Here it will be, sir, positive direction, infinity. I said exactly. Here, sir, it will be towards it. So positive direction, infinity. And here, sir, it will be towards it. Negative direction, infinity. And finally at infinity, 0. Now see the graph. Okay? All students, look at the graph here. See the graph here. Okay? I'll make it with this color. With green. Let's make it with blue. Okay. It's infinity in the positive direction, and then in positive, it started from here. This started from here. The graph will be something like this. First thing, some students will make it like this. Some students will make it like this. Wrong. Our graph will be like this. First thing. Second thing, sir, minus infinity here, there is no null point. Yes. And, sir, there was a null point here. Some students make it, sir, from minus infinity to 0. Those who did this, 0. Gone. Why, sir? Because there was a null point, buddy. This is how the graph is. Its graph is like this. Do it, brother. First make this. Now, where will the problems come? Understand carefully. Many students, we know the null point, so the value of x. Now, the student who's troubled by the null point, that means you didn't revise force. The value of x, d upon root of 4 minus 1. Root of n minus 1 was there. So, d divided by 2 minus 1. So, at what value of d will your null point come? Your null point will be at x equals to d. So I hope there is no problem in where the null point is, sir. Yes? Second doubt. Sir, why is it asymmetrical? See, to think so much, why is it asymmetrical for us? Why isn't its minimum exactly in the middle? Okay? At d by 2, its minimum will come. But sir, if we look at its minimum, you're saying it will come here. Come on. Now they haven't asked this in advance yet. But if the question comes, they can definitely ask this. So now I have a question on this. Which one was this? I think A, B, this one was C, and now here is D for you. One charge that we have is Q, and one charge is N times of Q, where N is greater than or equal to 1. Separated by distance D. Now, this will become a JEE advanced question for you. Find at what point between the charges, the electric field is minimum. The electric field is minimum. Did you hear my question? Between these two, which point will it be? Where will it be where the electric field is minimum? Now you tell me the approach. Sir, in the first one, how did you call it a null point? You come without revision, yaar. Come on. You worthless person, there's no null point in this, man. Oh, man. Come after revising, brother. Okay, come after revising. Don't do today's class, brother. Told you. A lot of previous things will be utilized here. Where am I trying to take you and you are asking a worthless question? In the previous one, there was a null point. There is no null point in that, yaar. You understood this, that when we have unlike charges, positive and negative, the electric field is minimum somewhere. The electric field is minimum somewhere here. Yes, sir. So now if I ask you, where is it minimum? Then brother, if we assume I ask for the electric field at some x distance from here, then what will happen because of this, sir? KQ divided by x square. And sir, because of negative, the electric field will also be this way only. How much will it be? Sir, K and Q divided by D minus x square. Sir, don't get angry. Why shouldn't I get angry? 10 classes have gone on, brother. I taught you with full dedication, taught with full honesty. And still you're asking a worthless doubt. So do you want to stay at that level? So I keep giving you petty questions and you stay happy forever? Or should we raise the level, brother? Now 10 classes have done. If I don't teach you now, when will I teach, brother? Understand here, between them the electric field is always this way for positive and this way for negative. It will never cancel out. I explained this too. Electric field can never be equal to 0 in this case because both electric fields are adding up. Here you have electric field plus infinity. Here you have electric field plus infinity. Very large, very large. And both are adding up. So somewhere in between there must be a minimum, right? Yes. Yes, so how do we do it, sir? So brother, maxima, minima, electric field at any x. If you talk about the electric field at any x, what will it be? My boy, KQ divided by x square plus K times NQ divided by D minus x square. What do we do in maxima, minima, sir? Sir, in maxima, minima, we differentiate and then set it equal to 0. I said, okay, do it. dE by dx. So sir, take kq out as its constant. Write the differentiation of 1 upon x square, brother. d by dx of x to the power minus 2. What will it be, my boy? Right? So this will come minus 2x to the power 3. Then we have plus n times. Here your remaining part is there. This will come minus 2 into d minus x cube. Okay, we have minus 3 here. Okay, minus 3, and apply the chain rule, it becomes minus 1. This will come. Clear? So all students see this kq, and what will this be? Minus 2 divided by x cube. Yes, sir. And minus plus, we have 2n divided by d minus x whole cube. Yes, it's clear for us. Clear? This came. Now if you see, you can take 2 common from here too. Then what do you do with this? You equate dE by dx to 0. Yes? So the moment you equated this with 0, what will we get? This, sir. We have to make this 0. 1 upon x cube is equals to n divided by d minus x cube. So can I say 1 upon x is equals to n to the power 1 by 3 divided by d minus x? Yes. Cross multiply, d minus x is equals to n to the power 1 by 3 into x. Take it here, d divided by 1 plus n to the power 1 by 3 equal to x. Who all have got this? Give me a thumbs up. Yes. All the students who all have reached this point, please acknowledge that yes, we have reached here too. So all this hard work has paid off. This power came forward and in one power it became minus. So minus 2x to the power minus 3. Constant was there, kept outside. Its power came forward, minus 2 d minus x to the power minus 3. This is chain rule, my boy. You're not differentiating x, you're differentiating d minus x. D becomes 0, x becomes minus 1, and that's how we solved it. Yes. If some student will say, sir, do we have to memorize this? I'll say absolutely not. But when you know JEE Advanced is asking such things, then keep the analysis ready. If n is equal to 1, so x value is coming out to be d by 2. Meaning, on the midpoint, it will be minimum. Who have understood this? On the midpoint will be the minima. Symmetrical. Sir, why did you shift this? It was done because the value of n here is 4. Understand this. Now this result became useful for you, my boy. If n is equal to 4, what's the value of x, my boy? D divided by 4 to the power 1 by 3 plus 1. It is smaller than d by 2 for sure. For us? Yes, sir. So, this minima point of yours, the electric field that has become minimum, at what distance has it become minimum? The value of x is d divided by f 4 to the power 1 by 3 plus 1. Yes or no? Is this clear? All students. Is this clear? So, JEE Advanced hasn't asked this question yet about where the graph's shifting will be. So you should know that it's not necessary that both act in the same direction and it comes exactly in the middle. So sir, why didn't you check maximum minimum for the electric field? Because we don't need to, okay? So, we have got this result for you. No need to memorize it, but you could have solved it yourself. Clear? Now, for example, let's say this is your question. Listen carefully. Listen carefully. One was plus q. Okay? And one was, wait. We have minus. Okay, we can take 64, right? Minus 64. Okay. All students, now make its graph. See how many students can do it. Those who want to leave, you can go, brother. Sir, here the electric field is this way. And here, I guess you guys don't deserve it only. Some students out of you don't deserve. Okay? Your hard work is like that. You don't deserve it. What are you fighting for, brother? Just tell me. This is our question. Now make its E versus R graph. All positive will be away. This in negative direction, infinity. This in positive direction, infinity. We're fools, aren't we? That we are ready to put in Sundays with you too. When the Lakshya batch was launched, you quickly get into the comparison mode. So the teacher said, brother, just follow what I say. You have a lot of doubts. Should I do it from here, from there, from here? I said, brother, I'll teach so much on this board, your mind will start leaking. Whatever you can hold, that's your capacity, handle that much. And this is just start. Okay? This has just started. Understand? If you keep running here and there, run away now. Now all students see this. But here, what will we have? Sir, here it's positive direction. So plus infinity. And I told you in start, my boy, I need hard-working students. I need absolutely crazy students. I need absolutely crazy students whose every day is either do or don't. Don't study with me, brother. There are many great teachers out there. Go study comfortably. I need crazy students. And I'm telling you upfront, those who studied with me in Arjuna, the way I teach on the first day, I'm seen teaching the same way on the last day. You won't find a change in my energy. Okay? You won't find any variation in the concepts either. The love with which I taught units and dimensions, I taught wave with the same love, or rather double. Okay? If you don't have the consistency, you'll get cut off the middle. Got it? I need an absolutely crazy student. Very few get selected every year, and that crazy student will get selected. Okay? I won't do much for the crowd anyway. Give a holiday, give this, give that, sir. We have this in school today. Who told you this preparation would be easy? Whoever told you, my boy, that preparation is easy, study with them. Study with them, brother. Okay? Study with them. You'll find out. Give it 5 months. Let magnetism come. You'll find out what it is. You will get to know yourself. First thing, sir, there will be a null point here. Yes. Which charge is larger for us? Sir, this is the smaller value of charge. We don't look at the sign. So, where do you get the null point? The null point will be towards the smaller charge, sir. Somewhere here. I said yes. So, what's the distance of this null point for us, sir? The distance of the null point, I'll make it here. Okay? The null point we have, my boy, listen carefully. That is x equals d upon root of n. The value of n for you is 64. 64. Okay? And when there are unlike charges, root of 64 minus 1. This will come for us. So, this will be d by 7. At what distance will it come? D by 7. Now make the graph. Sir, this is in negative infinity. There is a null point here. So, the graph goes something like this. Then it goes like this and like this. We'll come to this too. Okay? In JEE Advanced, they only asked to make the graph. We'll come to this too, but yes, sir. Sir, what will be the graph like here? There is no null point here, no. When there are unlike charges, the null point can be outside but will be towards the smaller charge. So this is your null point. So here this is minus infinity. I said yes, and it will go towards 0 like this. Clear? One student is saying, sir, cube root. My boy, that was for the middle one, for the null. That's why I gave this question to you. Plus infinity, yes. Your graph won't be symmetrical. Some students make this. No, this is wrong. This is wrong for us. We still have some students. The graph will be like this. Okay, I'll make it like this. This electric field will be minimum somewhere here. The calculation that we did earlier, my boy, that was x's value, that is d divided by cube root of 64 plus 1. 64 plus 1. Now students got confused between the null point formula, and that's why I'm saying don't memorize its formula. But you should know that the graph will shift. This will not be at this point, so this will be at d by 5. Here, your electric field is minimum. And this is your null point. Okay, this is your null point. This is the distance of the null point. There is a difference between the two, my boy. I taught this too. I taught this too. Now, your homework, sir. Why did it go up and then came down after going up? Understand, at infinity, what is it? Electric field, sir, is 0. I said yes. What's the electric field here, sir? 0. And here minus infinity, meaning very large in the negative direction. It decreased, became 0. And then here to 0. So now there are two options. Either it increases to 0 or it's directly 0. Understanding what I'm saying? Sir, here the value was very large in negative. So as you go on, here the electric field will be 0. And after that, you won't get any electric field like this. And sir, then there's some value over here. And in the end, it has become 0. So something like this. Now in your homework, you have to do this. Listen carefully. Here, put dE by dx equal to 0. Got my point? dE by dx equal to 0. And find the point where the electric field is maximum again. This is your homework. Will you all try this, all students? Sir, please show it with the animation. There is no animation for this. This is a JEE advanced question. Not every JEE advanced question has an animation. I can try. Wait, let's see. Maybe it will work. See, this is positive, negative. You won't get any electric field 0 anywhere. I keep making this charge larger. Let's see. Maybe here you'll see the electric field becoming 0. Can you see over here, electric field will become 0 somewhere over here. Now see. I'll try once. Okay. Now we start moving in this direction. This is minus infinity. This is very large for us. Okay. Minus infinity. In that question, the negative one was larger, right? Okay. But it's fine. You'll understand from here. We don't have 0 anywhere. There is no null point. Yes. As you go this way. Now see for us. As you go this way, there is a very large value there. This is there, this is there, this is there. Now I don't know the value in between, okay? We've put so much positive that it will show the minimum here or not, I don't know, okay? This became the minimum here. See, this became the minimum. Where did our minimum happen? Near the smaller charge, sir. See the value here? How large is it here? Yes. Now as I go towards this smaller charge, listen to my words carefully. You will see the electric field decreasing in size. Somewhere here, somewhere, okay? Somewhere here the electric field is minimum, okay? Now see, the electric field becomes minimum, minimum, minimum. Now it slowly starts increasing again. And then what did this become for us? It became like infinity. And if I come here, sir, suddenly negative infinity, sir. Now understand carefully here. If you stay near it, minus infinity, yes. Now as I move here, move, you will get a null point. Okay? The electric field was 0 somewhere here. The electric field was 0 here. One very heavy charge and one small charge. Null point always will be towards the small charge. It will be towards it, sir. It doesn't happen in the middle. In unlike charges, the null point is either here or here. Towards the small charge. This way, yes. Then now see, as you increase here, now see, what was the sign here? What is the sign coming after this null point? This. So the direction of null point has changed. Yes or no? Are you able to see this? This was the null point. Over here the electric field was this way and over there it was that way. And on null point it was 0. Electric field earlier was in negative direction and after the null point it is becoming 0. That means electric field is changing the direction, right? Then after this, if you see, from 0 the value rises up a bit. And as you head towards infinity, it starts dropping back to 0. Okay? Got it? Over here, the value peaks after the null point. The null point was right here. After this, the value climbs. Yes. And then after this value, it slowly decreases until it hits 0 at infinity. Then somewhere along the way, you'll get a local maximum. Yes or no? Yes or no? Is this clear? So, This question hasn't even been touched by JE Advanced yet. JE Advanced is asking for all these crazy things, graphs and whatnot. Then why should we shy away from the mathematical analysis? Got it? Yes. Very good. So, first up was your E versus R graph analysis. Clear? All you kids. Let's move forward. Okay. Force between a ring and a rod. Now, I'm pausing your chat for 1 minute. Listen carefully. Look, you guys haven't done integration in mathematics yet. Differentiation and integration. Differentiation is a breeze, but integration is a beast. So now, when Ashish sir starts teaching you integration, then this integration will feel like a walk in the park, okay? Right now, you're probably thinking, man, integration is tough. Today, we are doing some solid level integration. So at least your target should be, alright, sir, if I learn integration from Ashish sir in maths, I'll get a better grip of this later. Physics formulas, I mean equations, I think you are integrating, that's math, okay? But getting to the point where you need to integrate, that's physics, okay? That's physics. I'm saying at least we understand that part. And I'll make you do a bit of integration too. Once you do it in the maths, it'll feel easier. When you revise, it'll feel like a breeze. Now, what do I have here? Listen carefully to the question. Let's see how many of you have the will to tackle this. Okay? Only the one who has the will to tackle this, that I have to learn slowly, 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 you'll nail it. But if you are not there and you are just here to whine and cry, that's a different story. Now listen to my question. There is a ring and on its axis I've placed a rod. Nice and easy. We'll do it this calmly. Here is the data. Super simple. Charge is plus Q. I'm keeping it straightforward so that you can focus on the analysis more. And we've also got a charged rod here. Length R. Okay? With the length R. Okay? Here we have a charged rod with the length R. Find the force between these two. That's my question. Now see. Some of you are thinking KQ and Q2 by R square. I'll just give you a tight slap. That's for point charges. Do these look like point charges to you? Do they? No. Do they look like point charges to you? So how do you find the force? All you kids. I need the force between these two. How do you find the force? Think. Tell me the first step. Sir, find the force between them. But if you haven't thought of the first step, you're not going to get to the next one. K, Q1, Q2 by R square? Absolutely not. That's for tiny point charges. Rods, rings, discs. No, that doesn't work there. Integration. 100%. But what formula will we use in the integration? You don't even know that. Now understand. Whenever you're dealing with force, keep this in your mind. Keep this in your mind. If you know the electric field, put a small charge in it. Take a small charge in it. Process, see the process. Charge in it. And find the force that is equal to Q times E. That's what we used to do. All of you kids, think through this process, okay? On the axis of it, on the axis of the ring, did you know the electric field on it? Tell me that. Can I think of it like this? That, brother, I can't just plug it in a formula over here, no doubt. But let's say I've got a ring with charge plus Q. Okay? If, let's say, I've got a ring with charge plus Q, radius is R, and at a distance x on its axis, electric field that we have over here. You know the electric field value there? Yes. Now some of you say, sir, you make us memorize the formulas. If you won't know this, then go and derive the electric field formula and come back to this question. It will be so big then. Sir, due to the positive charge, the electric field is KQX divided by R square plus X square to the power 3 by 2. I said, great. If I place a small charge dq in an electric field, then can you talk about a small force? That, sir, we will write its charge into E, which is Q into E will happen, sir. So, sir, just find dq somehow. So, understand this. What's the length of the rod? I took a small charge of it. Length of the rod, that is equal to r. So, unitary method, on length r, the charge is, my boy, plus q per unit length. The charge is, sir, q by r. I said very correct. Sir, if I take a small dx length of charge in this, what will it be? Q by r into dx. Sir, this will it be. No crying. Your inner voice should say, yes, sir, force me to think. I'll think. Otherwise, I won't crack this in the exam. Have you understood the approach I'm building over here? See, brother, two small charges. You apply the formula directly. I applied it too. No difference. Now, I need the force between a ring and a rod. Remember, we found a force between a point charge and a rod, right? I said you'll have to integrate. Took a small element in the rod. That's why I gave you a target by Friday that cleared the backlog. Took a small element in the rod, wrote the force between them, then integrate to make the rod. I said, man, the electric field of a ring is known. I'll take a small charge here at x distance of dx length. Okay? If you place a small charge in an electric field, the force is q into E. So dq into E, I can say the small force that comes, the value of dq came. We have q by r into dx, and the electric field value is, my boy, kqx divided by r square plus x square to the power 3 by 2. Sir, why not directly find the force? Hurry, my boy, you can't find it. In the electric field formula, x is a variable. Here some force will act, here some other, here some other, here some other, here some other, here some other. What was our electric field? Force on 1 coulomb. If your charge is here, the value of x is 0. There is no force here. As you go further, x will vary, okay? The force will vary. So, brother, you will be able to find it after adding only. Yes, now see here, total force. That is equal to, sir, this comes out to be kq square x dx, kq square x dx divided by, what do we get over here, my boy? R into r square plus x square to the power 3 by 2. This is made, right? Now, sir, the matter of finding the total force, we have to find the total force, so we have to do the integration. So I said absolutely. All students, find me the variable and tell me the limits, okay? Then it's maths only after that. Even if you don't understand that, no problem. Ashish sir will make you a pro in that, for sure. Tell me this, variable and limits. Variable and limits. Where do we see the variable? Sir, the one with d written is the variable. I said yes, the variable is x. Now all the students tell me, this charge particles, this charge particle we have here, where do I place it from where to where so this system works? Very good. Sir, integrate from 0 to r. Your question is done, my boy. Done in terms of physics. Now I know maths might give you a bit of trouble, so we'll do it without stress from here, okay? Understand what did Ashish sir say? You should have blind faith, okay? So from here, without stress, physics is done, now maths start. Okay, so now I know you don't know any direct formula, but this is called integration by substitution, okay? See now, take the constant out, kq square by r out. In the integration, it was x dx divided by r square plus x square to the power 3 by 2. Sir, how do we integrate this, sir? Understand this. I said let r square plus x square be t square. I assumed something. If you differentiate this, then this will become 0 and this will come 2x dx is equals to 2t dt. 2 and 2 gone, the value of x dx comes t dt. If you see, I can write this as kq square by r integration. I can write this as t dt, and r square plus x square was taken as t square. So this will become t cube. That means kq square by r in the integration dt by t square. Those who want to leave, you can go. Okay? I'm not taking this class to scare you. I'm absolutely not taking it to scare you. If you have the access of old archives, just go and see. Open it and see. We do all these things every year in Lakshya. Okay? Every year. So that means this is a standard level. If you want to go to JEE Advanced, okay, boards and JEE Mains are done. Now JEE Advanced is the talk. So this isn't for everyone. Those who crib, it's better you leave. Okay? Sir, this is 1 upon t squared. I know its integration. That's what it is called. You can easily find it. So this came to be kq square by r. Yes? kq square, and the integration of 1 upon t square is minus 1 by t. Sir, where did the limits go? Wait a bit. We had taken r squared plus x square as t square, right? So under root r square plus x square, that is equal to t. Now see once. kq square by r. If you put in the value of t over here, now the limits, the ones you said for x, put those 0 to r. So upper limit minus lower limit, this will kq square by r. Yes, sir. We will put the upper limit. So, sir, minus lower limit minus upper, do it. 1 upon under root of r square plus 0 square minus 1 upon under root of r square plus r square. Your answer will come, okay? kq square by r. So, this will become 1 by r minus 1 by r root 2. So, the force that comes, my boy, between a rod and a ring is this. Is it clear? Is it clear? Yes or no? Is it clear? Sir, my head's spinning. Okay, let's close the class, brother. You study in your own comfort zone. I'll record it, my boy, and give it to you. Okay? I'll record it and give it to you. This will become squared, na? I'll cancel it. There's one above too. Let it be, man. Forget it. I thought maybe it's okay. No problem. Let it be. I had thought a lot that we'll do this, we'll do that, but no problem. Let it be. This batch is like that. Can't accept much. Okay. Whenever we will have time, we will do it at that time, okay? I said at the starting of the class too, it won't work, brother. If you don't understand, it's not my fault. If you think it's my fault, fine. If you think that it's my fault, okay. Then at the end, you will know who was right, who was wrong. I can say that only. I told you in the starting only to trust me. If you say, sir, I'll trust you only when you teach easy, then that's a different thing. What did I say? Whatever I teach on this board will be relevant, okay? You won't need to go here and there to look here and there. You have FOMO too, right? Let me see my friend's notes. Let me see what they are taught in his coaching. You have FOMO too, right? I know you will have it. If your friend brings one question now, you can't do it. You'll say, man, he's right. So, we have to teach relevant stuff too. We have to end your FOMO too. We have to make you feel confident too. You've put all that work on me only, all that burden. That's what it means, right? Okay, brother. You guys go and manage however you want to. Because the questions in JEE Advanced use basic concepts only. There's nothing dangerous applied here. If you are a different kind of a crybaby student, then that's another matter. Okay, brother? The concept was this. Force equals QE. Took the electric field of a ring, took a small charge, integrated it, got the answer. Now you can't just say, sir, you didn't teach JEE Advanced. I taught JEE Advanced also. It's just that your practice is less. You can accept that. Okay. There are a lot of good things, although. Alright, now what? what all had I planned? We'll combine vertical circular motion with electrostatics. We'll find the force between two perpendicular wires. We'll find the force between an arc and this semicircular ring, linear. This is your Irodov question, okay? This is your Irodov question, tension in the ring. These are 3 or 4 questions that came in JEE Advanced. Rod's rotation in an electric field. Your JEE Advanced question. Electric field due to a disk. This is your JEE Advanced question. Oscillation time period had to be found in the electric field of a charged pair. Series based. Very good question. These are all your Irodov questions. If you don't want to do it, what can I say? Now you're saying please. See, Sunday is ours too, you know. Sunday is ours too, to be honest. And I don't want to teach you by making you emotional, brother. That I have this problem at home, that problem. I wanted to teach. I came. But if you don't let me teach, my mood will get spoiled now, brother. And I won't teach nonsense, brother. Got it? Okay. I'm giving you one more chance. Because, brother, see, my loss is very little. Okay? My loss is very little. And advanced, how do I explain to you? Advanced doesn't happen by wanting it, brother. You think you'll want it and you'll do JE advanced, you'll watch reels in advance, will get cleared. It doesn't happen by wanting, it happens by doing. And I told you earlier, the day your condition starts getting bad in physics, understand you're in the right direction. Got it? So far, we've only taught 2 topics. I haven't gone to electric field lines yet. I could have taught that first. Today's class, we could have done electric field lines. It's a 1 lecture topic, not much. And then advanced, which I would have given you recorded. I know some watch and some don't. You come for the live session, there's interaction, you learn something. And I know many of you stopped watching midway. Oh man, this is getting high level, this is that. This is the same way you messed up your class 11th. The same attitude with which you messed up your class 10th. What difference are you creating in your life now? With the same attitude, same approach, you're expecting different results? It is possible? Is it possible? Tell me, brother. Everyone's stressed out about class 11th. You have class 12th in front of you, and you're not valuing that. Last year, when it was class 11th, you were crying differently. Your attitude has become one of crying. Your behavior is like that of class 10th students, and your dreams are so huge. And you have huge dreams. Oh my God. You've nurtured big dreams. My boy, those same dreams will slap you every day. Your hard work is zero right now. And when someone's trying to pull you out of that pit, you'll curse that same person. You're going to curse the same person. Because that's become your nature. Just comparison, FOMO, panic, anxiety. That's what you have. Understood? Come on. In the same way, if I give you to find the force between 2 rods, like now, you don't know integration, it will come with practice slowly. Suppose I add in a question, new question, and you make a function. Okay? I have 2 rods. 1 rod here, 1 rod here. Now let's see who all use their brains. This rod's length is what? L. It has plus Q charge. Okay? The concept should start running in your mind. Okay? I am giving simple data at the distance. I could have given L1, L2, L3, but I don't want to complicate it unnecessarily because I don't want to get stuck in the maths. We need to build the physics logic more. This is the second rod. We have plus Q charge. Its length is also L. Find the force between these 2 rods. Find the force between 2 rods. You have to tell the force between these 2 rods. Okay? Now, sir, how do I do it now? Should I, sir, apply K, Q1, Q2 by R square? I'll ask you one question. Are these point charges? The condition of Coulomb's law was that you can apply it between 2 point charges. Are these point charges? No, sir. These are spread out charges, sir. That means, sir, integration will come. Now, what comes to many students' mind? Sir, I'll take one element here, and then write it here. So you'll have to move this too. Only then will be the rod formed. Yes, sir. You will have to move this too. Then only the rod will be formed. Yes, sir. Right? Sir, double variable integration isn't even there in our syllabus. When you go to higher studies, when you do graduation, triple integration will come in your syllabus. It comes in the first to second semester only. Okay? Second semester or first semester, in the first year of BTech itself, you'll be taught triple integration. In our syllabus, it's single variable, meaning only one thing can vary. Not that this particle moves and that particle. That's in BTech. We'll only talk about single variable. How do we do it, sir? I said, man, we had a result. Use the result. Sir, you make us memorize formulas. Derive it. Come to this point. I'll just have more speed than you, that's all. I taught you how to do it, didn't I? Taught you how to write the electric field due to one rod? Yes, sir. Some students might have taken it lightly. Sir, KQ upon D into D plus L. This was the electric field. And if I write it in simple language, it was something like this. KQ by L into 1 upon D minus 1 upon D plus L. If you look at the second last step of the integration, it was something like this. If you solve this, then take LCM, D into D plus L. So here D plus L minus D, and L will cancel. This was it. This was the electric field. Yes, sir. Now you know that if you place any charge in any electric field, a force will act. F equals to Q into E. You know that much, right? Now, I am giving you a hint. We needed the force between two rods. They are not point charges. Yes. So should I start doing it like, man, one rod was this with charge on it? Now start moving the pen. Okay. One rod was this. I explained the process up to thinking that this has plus Q charge. Length is L, and at a distance x from here, I take a very small charge of dx length. What charge will come on it? You can apply the unitary method, sir. On length L, the charge was Q. On L length, the charge is Q. Per unit length, it will be, sir, Q by L. If you take the charge of dx length from this, it will come Q by L into dx. So meaning you have a small charge Q by L into dx. This is placed here. Yes, sir. I said now all students think how to start. Using the derived result, I can find the interaction between these two. I need the electric field. Listen to my words. I need the electric field. If I know the electric field, I can place a charge there and find the force. So I placed a small charge. What's the electric field due to this rod? This. And what will be the value? The same one you saw. KQ by L into 1 upon D minus 1 upon D plus L. Sir, this was the electric field. I said yes. If you place a charge in it, a force will act. Yes, sir, it will act. That small force that is equal to dq into E, sir. The small force acting on it will come for us. dF that is equal to dq. The charge on it, my boy, that is equal to q by L into dx. Yes, sir. And the electric field is, for sir, kq by L into 1 upon D. We should take x instead of D. Listen carefully. Here, instead of D, you took x plus L. What was D? It was the distance between these 2 points, sir. So I, from here to here is x for us. So I placed x instead of D. So here your result will come 1 upon x minus 1 upon x plus L. Yes? I'll simplify this for you. See, sir, kq square divided by L square dx by x minus dx divided by x plus L. Now all students, first tell me, are you able to think up to this point? In advanced, you get very good rank in 50%. But if you can think 10, 20, 30% today, then only you will be able to reach there. So are you getting the approach? That why I'm not directly applying k q1 q2 by r square? First, that should be clear. Second, sir, how do I approach this? Man, you know the electric field of one rod at some point. So if I have the electric field, I'll take a small charge there, sir. I'll take a small charge from this rod. Force is QE. So, sir, the charge was this. The electric field is this. So we wrote the small force, sir. Yes? Sir, the formula was this. Why did you write it like this, sir? Because in this, you have partial fractions and integration. So I won't go into integration, okay? The previous step was exactly this. When you took the LCM and solved it, this came up. I said if you do it this way, it'll look easier. Yes? All students, tell me the variable and think about the limits. See, find the variables from here because I need to find the total force. Limits, variable, that's what you need to do. Ashish sir will teach such solid integration that this will all feel like butter later. Think about this today. Don't take the load of what comes next. Didn't get it? No problem. Ashish sir is with us. Sir, the variable is this, which is x. I said yes. Now, think, where will you change x from and to? This was the rod. Yes. You have one charge. You have one charge that you can move because when you move it, your x will vary. Yes. So, what did we want, sir? We needed, sir, to start placing it from here and keep placing. Keep placing to make this rod here. I said, okay. So, when you are making this rod, where will the value of x vary from and to? Sir, at that time, the value of x should start from L. Your first one was this. And you keep placing. We need to make a rod of length L. So if we go up to x equals to 2L, sir, the result will come. Some students are saying from L to 3L. My boy, where did you start measuring x from? From here. Okay, so where do you need to place the first particle? You needed to place the first particle, sir, at x equals to L. This was your first particle and you keep placing it. Where will you go up to? Some students say go up to 3L. Oh, you fool. In this system, if I ask you to start running from here and reach till here, how much length will you have covered? Sir, here it's L and here it's L. So from here to here it's 2L. So I'll go from here to 2L. Then it will happen. That's what you had to do here. So it's 2L. So when you're finding the total force, it's kq square divided by L square. Okay? Understand the integration carefully. Integration dx by x from L to 2L. Yes, sir. Minus dx divided by x plus L from L to 2L. Now, if you know a bit of integration, 1 upon the integration of x will go into the natural log in the answer. Okay, so this will come kq square divided by L square natural log of x from L to 2L. Minus, we will also have natural log of x plus L from L to 2L. So the upper limit minus lower limit, my boy, kq square by L square. This will come log of 2. I hope you know. Log of 2L minus log of L. Log A minus log B is log A by B minus R natural log. When you put the value of x as 2L, it will be 3L and 3 by 2. Log A minus log B, kq square by L square. Natural log 2 divided by 3 by 2. 4 by 3. Who all have been able to reach this point on their own? Make a heart. One student saying, Pratiksha is saying, sir, from 0 to 2L. My dear, when you put 0, the first particle will come here because here your x value is 0. Did I need to make the rod from here? No, sir. Our first rod's element should start from here when the value of x is L. And sir, this element changes from here to where? Sir, it will reach 2L from here. And the answer will come. So the log part didn't make sense. My boy, we have the result of integration. Integration of dx by x is natural log x. And dx divided by x plus some constant, any constant, it's also natural log of x plus a. What steps did we miss over here, sir? Log a minus log b. Log a minus log b, that is equal to log a of a by b. Okay. So what will yours be? Log of 2l minus log of l. So log 2 we have, if you put 2l in place of x, it will be 3l. And if you put l, it will be 2l. So log 3l minus 2l, log 3 by 2, log a minus log b. That is the answer. Clear? So the force between a ring and rod, we derived this. Yes? Clear? Now listen carefully over here. Very good. Now listen carefully here. I am disabling your chat again. Okay? The result that I am now going to tell you, you can derive this result from integration too. But rather than that, we need to use its result. Use its result. There is a question in JEE Mains and JEE Advanced too. Now listen to me carefully. By the way, a Pathfinder question is also coming to mind. Okay, let me write it here so it doesn't skip from my mind. I'm making a diagram now. This is a Pathfinder question. We can do that first, then we will come to this. I'm writing this, we will do that first, then come to this. If the rod is slightly displaced by x along axis, find the time period. We'll come to this. This is your Pathfinder question. The rod and ring reminded me this. Okay, if there's time, we will see this too. Let's come to this because first, its importance is more. Okay. Now, what do we have here? We have an angular ring and thread. Okay. The students who studied with me in Arjuna 1, they would have seen this formula. Okay. Some students comment, sir, we studied here and there. We didn't see it, so we get stressed. Don't take stress. I told them, as much as I'm telling you, I'll explain you slowly, okay? Slowly. Don't worry. How to use it, that is more important. The application of the formula is more important. The application of the formula is more important. If you want to derive it from integration, that's also a question from Irodov, okay? See, if I do integration here and then in this Irodov question again, it makes no sense, okay? This one, we have linear charge density, variable semicircular ring with variable linear charge density. You have to do integration in this, okay? So you'll learn it here. Now the matter comes to this one. Now think and see. I have a wire, a thread, okay? What do we have on that wire? Charge, okay? Let's assume it's a rod. There can be a charge on a rod, so there can be a charge on wire too. Now that wire is in what form? Semicircle. Meaning in the form of an arc. Okay. So the first formula I'm going to tell you, look carefully, that I have a wire in the form of an arc. Now it can be at any angle. Okay. So I'll give you a general formula. Now this can be positive and can be negative. Everything is very basic. This is in the form of an arc, my boy. Now this angle, sir, which angle will it be, sir? From 30 degrees. I'll give you a general formula. Then we'll talk about the particular cases. Understand? On this, what am I assuming right now? We have positive charge. Okay. What is it? Plus lambda. What we call this? Linear charge density. What do we call this? Linear charge density. Sir, how do we find this? This is charge per unit length. How much charge is per unit length? That's it. Nothing new. If I'm saying plus lambda, it's positive charge. If I'm saying negative lambda, it's negative charge. And that's it. Okay? What do we need before this? Does the electric field of a positive charge go away or towards it? Think about it. So it goes away, right? And the electric field of a negative charge, sir, is toward that charge. So now understand. We need a wire whose radius we have bent it to. Okay, radius r. This angle is theta. Total angle. Keep in mind. Theta is the total angle in the formula. Some students make mistakes in the formula. Total angle theta. How much angle is from one to the another? Theta. R is your radius. Some students don't pay attention to these. What's in the formula? Now, due to this, you have to tell the electric field at that point. Think slowly, don't rush at all. I'm explaining slowly. You have to tell the electric field here due to all these charges. Now think, should I directly do kq by r square? Think. No, sir, that's due to a point charge. I said yes. So in this, sir, there will be a lot of small charges. Yes. So, sir, you can't do it directly. You'll have to do integration. Is integration important for us right now? No. You make an angle bisector. Okay. What do? You make an angle bisector. Why, sir? Will you use your brain? You'll figure it out yourself. Whatever electric field there is, it will be on this line. Listen to my words. Whatever electric field is there, it will always be on the angle bisector line. Why? Understand. Sir, I take a charge here. I said, okay. So, sir, the electric field due to this will be like this. Let's assume this angle is phi. No need to derive this. You took a charge here, sir. It's at an angle phi. So, it will be phi here too. Yes. So, E cos phi you'll get here. And E sin phi you'll get here. Yes, sir. Just like that, totally duplicate is also over here. Yes, sir. So the electric field value will be the same for this as well. Yes, sir. This is also at the same angle phi. It's symmetrical element. So this is also at angle phi. Yes. So the electric field value will be the same for this, same for this. But if you see these sine components, what will they be for us? They'll cancel out. The cos components will add. And the integration of cos will happen. So the answer will come in sine. First thing this, and the second thing, understand here, whatever result came, which line did it come on? It came on this line. That's why I said whatever your result, the electric field will be on the angle bisector. Okay? So the result I'm telling you, where will you make it? At angle bisector. Net electric field always on this line. Now, keep this in mind. Electric field is a vector, so direction is important. If it's positive now, then away. On this line, like this was a positive charge, so the electric field will be away here. This will be your electric field. Sir, if this was negative, sir, I said every point would be pulling towards itself. Yes, sir. Electric field, electric field, electric field, electric field, electric field, electric field. Where was the resultant? In the middle. Where was the resultant? In the middle. Where was the resultant? In the middle. So adding up everything, you would have got this. If it's positive, then here. If it's negative, then towards. Which line will we always make it on, sir? We'll always make it on this line. Okay. What's the value of the electric field? That is 2k lambda by r sine of theta by 2. Listen carefully. All students. If you want to derive this, you can. Some students say, sir, wasn't it cos theta in the resultant? So how did it come in sine, sir? My boy, you'll have to do its integration. The integration of cos will go to sine. That's why this comes. Okay. 2k lambda by r sine theta by 2. What's this lambda? Charge per unit length. If you have it in the form of charge, then sir, what's r? R is radius. What's theta? Total angle. I'll explain you how to use it in a moment. Okay? For different angles. First, you all write it. All the students write it. Sir, if this is negative, it will be toward. The line is always on the angle bisector. If the total is 60 degrees, then 30 and 30 towards. Sir, if this is positive, now wait, write this first. Sir, theta by 2, yes. All students, write this down. Now I'll teach you how to use it, sir. Sir, derivation, my boy, this is an Erodo question. I'll do its derivation there too. I'll do that one too. Okay? I've written this formula now. I've also written that the application of the formula is more important. If it's about derivation, you can do it yourself too. What I've taught now, run your pen once, okay? Yes. Yes. Now, sir, what's its application? Like now, listen carefully. You'll find questions in HCV too. You'll find questions in JEE Mains too. Listen carefully. Suppose I tell you that I have a semicircular ring. What is it? Semicircular ring. Listen carefully. What charge? What charge did I put on it? I gave minus q charge. And the radius is r. And radius is r. All students, see. Tell me the electric field at O. E at O. Now first thing. Okay? All students, step by step. I'm going very slowly. All students, see. Sir, the electric field of a negative charge is towards... Yes. So this is our angle bisector. I said yes. What do we make first? Angle bisector. What's the total angle? Sir, the total angle is your 180 degrees. Total angle is 180 degrees. We have 180 degrees. Say it 180 degree or say pi. That's better. I said okay. So the electric field, sir, will be on this line towards. So it will come in the upward direction, sir. The electric field will come like this. This is your electric field. Very good. See the value of E, sir. 2k lambda by r sine of 180 by 2. I said okay. 180 by 2 is 90. And sine 90 is 1. 2k lambda by r. Now lambda isn't given in the question. We'll have to find it. The value of lambda is how much charge per unit length. Charge per unit length. So see with your brain a bit. The charge is q, right? Some students say, sir, minus q. Now the electric field showed towards. The charge is q and the length is pi r. So see, this will come 2k divided by r. Q upon pi r. So this will come 2kq by pi r square. That is your answer. Tell me. Clear? Clear? Done. That's all you had to do. All students, talk about this first. Suppose I have a quarter ring. It had a positive charge on it. All students. Let's now slowly start doing it. Okay? All students, slowly, you'll start doing it here. I gave it a charge Q. Radius is R. Radius is R. Find the electric field at, find the E at O. Come on. Come on, brother. Let's do it. All students first. What's the total angle? If you see the total angle, sir, where do I find the total angle? From one end to the other. So this is your total angle, theta. That is equal to 90 degrees. Very good. Now, if you ever find the electric field, sir, we'll always find it on the angle bisector. I said yes. Now tell me, in which quadrant will the electric field be? Let's see how many students are able to do it. Students make this mistake in direction. In which quadrant? Sir, it will be in the first quadrant, second, third, fourth. Now what he's saying is just nonsense only anyway. Should it be in first or fourth or first or third? In which quadrant should the electric field be? Tell me. Very good. Yes, sir. Sir, it's positive the electric field will be away. The electric field will be in this quadrant. And what will be its value? Sir, 2k lambda by r, sine of theta by 2. Sir, 90 by 2. I said very correct. Now see, 2k lambda by r, sine of 45 degrees. So, sir, this is 1 by root 2. So, see this. We have 2k lambda by r. This is 1 by root 2, or I'll just write it directly. Root 2k lambda by r. Now lambda is given. Very good. Just find lambda. Sir, lambda is charge upon length. So, sir, the charge was q. The length is pi r by 2. Right? Or do 2 pi r by 4 or pi r by 2. So, this will come 2q divided by pi r. So, put this here, okay? Put it in. So, what will this value be? We have 2 root 2 kq by pi r square. Who all have got this answer? Make a heart. Very good. You're understanding how to approach it, the approach to the formula. Now I'm giving you one question. Try them, okay? Let's go. Let's see how many students do this correctly. I have a ring like this. A ring, okay? It had a negative charge on it. Let's see how many students can do it. The charge is minus q. Its radius is r. Okay? The angle is 120 degrees. Let's see how many students do it. Come on. We have. Where do we need to find the electric field? Always at the center. Always at O. Third question. Fourth question. Do it, do it, do it, my boy. Try. It'll happen slowly. Believe me, it'll happen slowly. And it'll happen only through this path. Plus Q. Radius is R. Radius is equal to R. Electric field at O. E at O. Come on. Let's go, let's go, let's go. Let's see how many students can do this. Sir, it's a 120-degree ring. I said yes. So, sir, first let's make the angle bisector. So, I said for 120 degrees, the angle bisector will be at 60 degrees. I said yes. This is your angle bisector. I said okay. And sir, because of the negative charge, the electric field will be towards it. So, the electric field's direction will be this, sir. I said very correct. So, the electric field that will be equal to, sir, 2k lambda by r, sine of 120 divided by 2, because the total angle theta equals 120 degrees. Very good. Many students are doing it. So this will come, sir. If you find the value of lambda, this is where mistakes happen. Say sorry, sir, you had to put q upon length. Now students forget that the length of the full circle, a 360-degree circle, is what, sir? It is 2 pi r. 120 degrees is 1/3 of the circle. 120, 120, 120. What's the length of the full circle? 2 pi r. So what will this be? Sir, this will be 2 pi r by 3. If you made a mistake here, then say sorry. What will this be? 3q divided by 2 pi r. So just put the value 2 by r. K, lambda is 3q divided by 2 by r. Students make very minor mistakes, and the sine of 60, that is root 3 by 2, okay? That is root 3 by 2. So this 2 and this 2 will cancel. So 3 root 3 kq divided by 2 pi r square. I knew there would be a mistake. I knew that, sir, the angle did not remember, sir, the length. Yes? Okay, many students matched it. Very good. Try the next question, my boy. Try the next question here. One is negative and one is positive. Now the electric field value of a semicircular ring, you know it, right? That is 2kq by pi r square. Now use your brain. Logic. What did we used to do first? I taught a clock question earlier. Remember? Q, 2q, 3q, 4q, 5q, 6q, like that. I taught a clock question. There were point charges. Here, they are distributed charges. Some students are saying it will be 0. Oh my God. It's not symmetrical, you donkey. The electric field of the negative one, sir. This will be your angle bisector. I said, yes. Brother, look carefully, you idiot. Those saying zero, you made a mistake without lifting your pen. The electric field of the negative one, sir, will be this way. Electric field due to two semi-rings. We derived it earlier. Sir, this was 2kq. I think kq by 2 by pi r square. Kq divided by 2 pi r square. 2kq by pi r square. Okay. So this is 2kq by pi r square. Some students suddenly changed from 0. The yellow one, negative charge, its electric field will be this way. Yes. And the electric field of the positive one will repel. It will be away. The value will be the same. The charge is the same. The radius is the same. So, what will be your net electric field? That will be equal to, sir, 2 times of E. So, this will come, my boy, 4kq divided by pi r square. That is your answer. Oh God. You guys have started going berserk. Right? We have one advanced question over here only I have in my mind. Although this is a magnetism question. Actually asked in magnetism. Asked in magnetism. But I've converted that question over here. Okay? Electrostatic. This question, I'll teach it again when I teach magnetic effect of current. That's our 4th chapter, right? Yes, 4th chapter. When we get to it, I'll teach this JE advanced question in pi by QS. I'm applying the logic of one of those questions here. Let's see how many students can think. It'll be a very good question and very few will think. And you have to challenge yourself. That's the main thing. This question hasn't come yet, but I'm telling you a question just like this. A question like this. Okay? You will get in magnetism a similar question. Let's see how many students can think like this. Understand the question now. What have I kept? We have semicircular rings. Semicircular rings we have for the first time. So you know its formula? We derived it just now of radius. Which radii, my boy? Listen carefully. Radius is r, 2r, 3r, 4r and so on up to infinity. Here too up to infinity. Here too up to infinity. We have kept it here. Okay, clear? We have up to infinity with all having the same charge q. All having the same charge q, having the same charge q. Find the electric field at O. Find E at O. Sir, GP. Some students are saying 0, 0, 0, 0. Okay. Do it step by step first. All charges. How much charge is on all the rings? Positive. Try it step by step once. See, all students, whatever the electric field is, it will be on this axis, angle bisector. First, this small ring. Let's find the direction of its electric field. All students, step by step. My dear, I said, your GP isn't forming. That you'll say that after looking at the data, right? Okay, tell me first. All the students tell me, if I start from here, I call this ring 1, I call this 2, 2r radius, then this is 3, then this is 4. We'll have to show up to 4, okay? This is r, this is r2r, 3r, and this is, mistake happened, 3r. This is 3r. And this one we have is 4r and so on. This is 4r and so on. You'll understand, okay? Where will it be? Very good. Very good. So, sir, even it will be this way for us. I said yes. And sir, you know now, for the semicircular ring, this semi is semi we just derived a little while back. 2kq by pi r square. Oh, a mistake happened here. Here it's root r, root 2r, root 3r, root 4r, like this. It's in root, my boy. It got easier. Root r, root 2r, root 3r, root 4r, and so on. Okay, so, come on. So if we talk about even's value will come, sir, 2kq by pi r1 square. So, sir, this will come to r square for us, okay? I said, okay, now. All students, now tell me for the second ring. Arey, what cheating? I told you na, I am converting magnetism question over here. So give me some time, okay? We will do it in root. Our radius is root 1, root 2, root 3, root 4 and up to infinity. All students. And anyway, your GP wasn't forming either. You idiots. Look at what they are saying. R, 2R, 3R, and if we square them in the denominator, they will form a GP. Wow. If you were in front of me offline, I would have kicked you out of the first row by now, for sure. Sir, because of the positive charge, the electric field will come this way. How much will E2 be, sir? That will be 2kq divided by, we will square this. So, sir, pi r square into 2. We can write it like this. It will be like this. Sir, the third one will be up again. I said yes. E3, if you see, sir, 2kq divided by pi, its radius, sir, is root 3r. So, pi r square into 3. We will write it like this. I said, sir, yes. Sir, E4, which will be down again. So, this will come to be 2kq by pi r square into 4. We will write like this and so on. It will keep going. Very good. Yes. What? Sir, where did r square go? Here we had the electric field due to a semicircular ring, na? So which was 2kq by pi r square. So I gave the radius as root 2, root 3 and root 4r. And for the first one, how much will it be, sir? In the upward direction, 2kq by pi r square. Okay. For the second one, root 2r. This is root 2r entirely. Okay. So if you square it, 2r square, 3r square, 4r square, like this. Okay. It's okay only. Clear? Yes. What's the problem? What happened here? Oh, so root is up to here. Okay, no problem. Now I get it. Root is up to here. It's root 2r. Now it's correct. Brother, this shouldn't just go away, okay? Let's just make it like that only. Go away. Just a slight mistake happened, yaar. Root r. Yes. Or, let me make the question first, yaar. 1 is r. Then it is root 2r. Then is root 3r. Then is root 4r. And so on. This is right. Yes. Yeah. Now it will come correct. So this one we have, let's remove the root, r, then root 2r. Now it will come correct. Root 3r, root 4r, and so on. Yes, now it will come correct. Very good. So, now it's come, brother. And so on up to infinity. So what will your net electric field be? Now, which series is forming? You tell me. There was no scam. I was still making the question. This hasn't come before, man. But the concept used in this has come in JEE Advanced. So while making the question, it goes up and down. All the students, see here, if you talk about the resultant electric field, what's your resultant electric field forming? Sir, that is 2kq. It's common in all. R square is also common in all. Sir, it will be 1. Look carefully. 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 and so on up to infinity. HP? Did you get what I said? You have to take this radius. So why plus minus, sir? Why plus minus? Brother, this is positive, this is negative. Positive, the resultant electric field is a vector, my boy. We can only add if they are in the same direction. We have taken this as positive, 2kq by pi r square. And this is in the negative, minus 2kq by pi r square. And this is what we have. So, one is positive and one is negative. One is positive and one is negative. And so on up to infinity. Now, which series is this? Yes, there are only a few students of advanced level, I guess. This is neither your GP, this is neither your AP or HP. This is actually log of 1. Have you been taught series in maths till now? Yes. All the students. In your maths, have you been taught the series? Sin x series, cos x series, tan x series. Have you been taught this? This is in 11th or 12th, I don't know, but it is somewhere for sure. All students, have you been taught this? And even if it was taught, would you have remembered it? Look at the attitude. No, no, no. Even if it was taught, would you remember it? Chain rule was taught to you. You don't even remember that. The series of log of 1 plus x that we have, okay, that is x minus x square by 2 plus x cube by 3 plus x minus x to the power 4 by 4 and so on. Such a series exists up to infinity. Okay? Yes. Now see, this thing was asked in JEE Advanced in a magnetism question. Such a series was forming. 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6. Such a series was forming. And in the exam, half the students did not even get it. Which series is this? Some know only GP, AP, HP. So this series of log of 1 plus x. And it will be taught to you in maths. Put x is equals to 1. When you put x equals to 1, log 2 will come. Yes. What will this be? 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 and so on. This will form for you. So, if you see, what is this value equal to? It's equal to log natural 2. So, your resultant electric field will come, my boy. Now, if this question comes suddenly in front of some of your friends, then they won't even know that what happened all of a sudden, brother. Where did this Ln2 came from? Now, this question was asked in advanced. Is it clear? All students? Yes. Sir, where did pi go? You take pi too. You're just stuck up on pi, okay? All students, did you understand the question now? So, brother, what is this question trying to teach you? This question is trying to teach you that series aren't just AP, GP, HP. You don't just stop here, okay? You need to know the series of sin x, cos x, tan x, log x, 1 plus x, binomial. All their expansions will be taught to you. Remember them well, okay? Is it clear? Okay, fine. If ticket on, sir, taught you in class 11th. Very good, very good, very good. Okay? So I'm repeating the question again for you. So what did I say? When I teach you magnetism, then there will be a JEE advanced question. In that, this series was used. This one. Got this? So, it doesn't just hit suddenly. That's why I'm telling you today. So, it will be relaxed there. Okay? Now, listen carefully. What did I do? What was our radius? R, root 2R, root 3R, root 4R, and so on. This we have. Okay? Sir, why are there charges? So, sir, their electric fields will be away. This one down, this one away, this one down, this one away. Now, some students think that these two will cancel out, these two. Now, the distances are different, right? Some students make it 0. Sir, this one's electric field is up, this one's down. The value is not the same, yaar. Its electric field will be, sir, 2kq by pi r square in the upward direction. It's positive. And this one, sir, will be in the downward direction because the radius changed. So what will be the electric field? Sir, 2kq by pi r and root 2 square is 2. Then I said the third one, sir, will be in the upward direction 2kq by pi r square into 3. And the fourth one, sir, will be in the downward direction 2kq by pi r square into 4. Now, if I talk about the resultant electric field, my boy, pay attention here. What will be the resultant electric field? This was a vector, my boy. You had to add according to direction. So understand here. This is in positive and this is in negative. This is in positive and this in negative. Then the fifth one will positive, sixth one negative. So 1 minus 1 by 2 plus 1 by 3 this came, and this is in the series of log 1 plus x. So when you put the value of x as 1, it's the series of natural log 2. Put it here. Is it clear? Yes or no? All students make a heart. My dear, if you talk about random things, then same old I explained just a while ago. All students, have you understood this now? If this question comes in front of you for the first time, obviously you'll say, sir, this feels difficult to me. Yes, it's bound to happen. Those students who would have seen this for the first time in the exam, the magnetism one, they wouldn't have even touched the question because they wouldn't have figured out what this series is. But today it's come in front of you, so that question will feel easy to you. Very good. Okay, now, electric field due to a thread. Then we will do Irodo questions, then I'll let you go. We will see in the next class after that. Electric field due to a thread. Next Sunday, okay? Next Sunday, we will continue this advanced lecture. Okay? Next JE Advanced on Sunday will be advanced because electric field lines aren't too advanced. And Gauss's law, our electric flux will start. At the start, it's not that advanced, okay? After that, I'll give you some questions and then homework. Then class over. You're all free, okay? All the students, listen carefully here. Okay? Now, those who were in Arjuna's first batch, okay? What time is it? Yeah. Let's see this formula. Let's learn how to apply it and then it's fine, okay? Now listen more carefully. Those who were in Arjuna 1, they would have seen this before. If you haven't revised, then you're back to 0, okay? And those who are new students, I'm telling you, I will explain you very slowly, okay? Let's assume that I have a wire which has charge on it. Now, sir, this charge can be positive or negative. It can be both, absolutely. Let's understand the positive one first. We have given a charge density on it, lambda, okay? Okay, and where am I asking for the electric field? At some point r, listen carefully, this is very important. At some point r, tell me the electric field here. This is not exactly in the middle, it's not symmetrical. I'll give you a general formula, then you have to think over here, okay? Tell me the electric field over here. So firstly, about the direction, let's assume this length and the same length if I take here. Are you getting my point? This length and this length are equal, so understand. All students. Sir, because of this one, the electric field will be this way. Yes. Whatever the value is, let's say assume it's E. Whatever it is, it will be this way. I said absolutely. Its symmetrical one is here. So, sir, because of this one, it will be here? Yes. Sir, because of this one, it will be this way? Yes, absolutely. It will be like this here. Right? Sir, and because of this one, it will be here. And because of this one, it will be here and so on. It will be like here for all of these particles. So, the first thing is, what? These pink particles I took, will there be any electric field in the x-axis because of them? No, sir. Why? Because the electric field created by this charge will have a horizontal component and a vertical component. Yes, sir. The electric field created by this one will have a horizontal component, sir, and a vertical component. So these two, sir, will cancel out. I said yes. So, did you understand this point that, brother, I am taking it like this. This is end 1, end 2. Here your angle is theta 1 and here your angle is theta 2. And this distance is r. perpendicular distance. If I need the electric field here, listen to my words, my boy. It's very important. If I need the electric field here, so firstly you will have to think, will there be components or not? See this once. How will it be thought? Sir, as much portion as this one is, yes, and as much portion as this one is, for this one, the electric field will only be this way. I said yes. Right? And these charges, sir, these ones are also giving an electric field. These are also giving their electric field. I said yes, they must be giving. So whatever the resultant electric field will come out to be, it will come this way and that way, both way. Have you understood this or not? Yes or no? All the students think. Sir, see, of these and these, the electric fields went like this. The resultant remained. I said yes. So this much and this much will definitely give this way. But sir, these extra ones here, their electric fields will also come like this, like this, like this. It will be this way and this way. Yes? For this, I have a small simulation. I hope you will be able to uh, see the integral one. Let me reduce the brightness a bit. Where is the brightness one over here? Okay. Okay. Let's see this rod over here. Okay. Let me keep it a bit far only. Okay. Lambda we have is positive. What happened? Okay. This. Okay, let me bring this over here a bit. Okay. This element that we have over here, as my element changes, see, the electric field of each element is different. Like this element is this, its electric field was this. I'll bring this point exactly to the middle. I'm trying that it comes to the middle. Okay. The electric field of this element was this way. As I bring it this way, see the electric field. Everyone's electric field is like this, like this, like this, like this. The one exactly in the middle will have its electric field here. The electric field of these points is like this, like this, like this, like this, like this, like this. Everyone's electric field is something like this, meaning all will have an x component here, y component here, x component here, y component here. The resultant you're getting over here. Okay? So, when you will vary the element, so everyone will have a different electric field. So, the resultant will be this dark line. This is your resultant here. If I decrease its value a bit, see this. Okay? So resultant is here. So it has two components for us that you need to keep in mind. Okay? For us, we have two components here. You'll use the formula slowly, and you'll get it perfectly. Don't panic. Okay? Your horizontal component, listen carefully, EH, that is k lambda by r, magnitude of cos of theta 1 minus cos of theta 2. Listen carefully. And your vertical component, or perpendicular, or parallel, you can call it parallel to. That's more correct. The electric field parallel to this one is this. This is k lambda by r, sine theta 1 plus sine theta 2. Now, many students will say, sir, we have to do so many formulas for JEE advanced questions. We have to do this. If you want to raise your level, you have to do this. All students write this down first. All students write this down. Sir, will you not do the derivation? Where it will be needed, son, you will not have to say. Getting my point? The thing which is going to be more required, it will be in your copy. Got it? And there will be some things too which you won't even require. So where I'm skipping, understand, instead of that, I'll tell you something which is more relevant. Okay? All the students. The integration that I'll do here has a lot of substitution in integration. There's substitution twice in integration. So no need of that. Instead, we'll do a good pathfinder question on time period in the next class. Yes? Now I'll teach you how to use it. Sir, I didn't even understand this. Now see. Okay? Application. Then I will give you homework, Irodose question. Try them at home. What is the application, sir? Let's assume that I have a wire. I'll disable the chat over here once. Okay. I will disable the chat over here. First is, let's assume I have a wire. This wire, what do we have here? Negatively charged. Okay. From here, it's still infinity. That means it's too big and very large from this side too. This is called the first case, infinite wire. All students, write this down first. For this, we have an infinite wire. I said, brother, tell me the electric field at a distance r from it. Got it what I said? At a distance of r, tell me the electric field. Its derivation is in the Gauss law as well. That is easier. That's why I've left it. Okay? If you do it by Gauss law, it will be easier. Okay? Otherwise, we will have to do very complicated integration unnecessarily. We have to tell the electric field over here. Now, my question to you all is, it's very large over here and very large here. So, sir, what's this angle? Theta 1. Theta 1 is the angle from perpendicular, this perpendicular line you drew, okay, to one end, till one end. Take it this way or that way. What's theta 2? Angle from the perpendicular to the other end. Got my point? This is perpendicular. Until I find the end, I'll keep measuring this angle. Okay? Sir, this end is up to infinity over here. So the angle I have to measure, I'll open it from here. Open. This. And until I see the particle, I'll measure that angle. So, sir, your theta 1 will come to be 90 degrees. Very correct. Sir, similarly, if I have to measure the end on this side, so if I keep measuring this end, then measure, I'll come to this. It will be theta 2, which will be 90 degrees. Yes. So, sir, your electric field that's parallel, that is k lambda by r. Mode of cos of 90 minus cos of 90. So, sir, this won't be there at all. We'll come to that. We'll understand. And sir, the perpendicular electric field, the value that's perpendicular to this wire. What is it? Perpendicular means perpendicular to the wire, parallel to the wire. So what's perpendicular, sir? That is k lambda by r. Sine of theta 1 plus sine of theta 2. 2k lambda by r. Understand that. That because of this negative, there won't be any electric field in the horizontal direction. In vertical direction, meaning along the perpendicular, what's the electric field of a negative? Towards. Sir, why aren't we making it upwards? Positive is away. If we have a negative charged rod, then electric field will be toward. Okay? So, whatever your electric field is, it will be like this. And it's how much? 2k lambda by r. Got the point? Whenever you get wires, if someone says, brother, find its electric field, you should know that there can be a parallel component, that there can be a perpendicular component. The formula for parallel is k lambda by r sine theta 1 plus cos theta 2 minus cos theta 1 or cos theta 1 minus cos theta 2. We need the value. What do we need? The value. How will you measure the angle? Sir, it is here. Its one end is over here. Yes, sir. So placing the pen from here, we will measure this end. This is theta 1. And from here, we will measure this angle. Sir, theta 2. Just put it in the formula, you will get it. If it's positive, the electric field is away. If it's negative, then it will be towards. Clear? Clear? Yes, one student said, sir, in parallel, all components will cancel out. Exactly. That's what you had to think, nothing else. Because of this negative, the electric field is this way. So both of their horizontal components will cancel out. Yes, the vertical ones will remain. Sir, this one's electric field is this and this one's is this. So their horizontal components will cancel out and their verticals will remain. So the resultant will always add up in the vertical. Clear? All students, let's talk about the second case. Let's see how many students get it. Semi-infinite wire. Those who want to leave, you can go. Sir, then we will miss it, right? It will miss anyway because you're a runaway human. If not today, then it will miss tomorrow. Some students are like, get the class cancelled somehow, brother. Because I have to go somewhere. I have some work. I have some more important things right now. If the class gets over, I won't miss anything. It will miss anyway because you don't have the capacity to think, okay? It'll either miss today or tomorrow. Okay? Keep getting stressed. Semi-infinite wire. Sir, semi-infinite wire means one side goes to infinity and we have it only on one side. I said, tell me the electric field here. Come on. All students, tell us the electric field here. Think. Sir, what kind of a wire is it? Let's say it is positive. Use your brain. This is a positive wire. Here the electric field. What will be the horizontal and vertical? And let's say I have this wire. I said this is negative charge lambda. And here it goes to infinity at r distance. Tell me the electric field. Come on. Let's see how many students get it right. For semi-infinite wire. Semi-infinite means one side goes to infinity. That is called semi-infinite. Yes? Now, sir, how do we find it? I said, brother, understand what's parallel? That is k lambda by r. Now, sir, we don't even know the angle, sir. K lambda by small r will be there, okay? Sir, we don't know the angle, sir. I said, place the pen. Rotate it on one side. Rotate it, rotate it, rotate it, rotate it, rotate it. This goes and goes and goes, sir. Sir, this end is very far, sir. It will be like this, sir. So, the end on one side will be found when your angle is 90 degrees. Very good. 0 and 90 degrees, and sir, one side won't have an angle. So on the other side, our theta 2 will be equal to 0 degrees. Will be 0 degrees. There is no angle, right? So on this side in parallel, it will come, sir. Mod of cos of 90 minus cos of 0. So sir, this came to be k lambda by r. I said yes. And sir, for the perpendicular, there is no talk of mod. K lambda by r, sine of 90 plus sine of 0. Sir, this also came to be k lambda by r. Clear? Now direction. Now direction you always have to figure out with your brain. All the students tell me the horizontal one, this parallel one, which way should it be? Should it be this way, first option, or should it be that way, second option? 1 or 2. Let's see how many students are able to think correctly. With your brain, 1 and 2. Which one should it be? Very good. 45 degrees root 2 times. Very good. Now tell me the direction. Let's see how many students are able to see that the parallel one will be in which direction. Very good. Second one, sir. Now use your brain. Sir, I'm not able to think. Oh. How are you not able to think? Where is the electric field of a positive charge? Sir, the electric field of a positive is away, sir. I said, okay. Over here it was still infinity. I said you have to tell the electric field here. So see yourself. Sir, this one's electric field will be this way. This one will be this way. This one will be this way. This one will be this way. Meaning all their electric fields, sir, will be like this. I said yes. So if you resolve all these, somewhere E resultant will come this way for you. And E resultant will come this way for you. So sir, it will be this way and this way. So it's done, right? So if I asked you this thing from here, so what's so dangerous about it? The electric field of positive will be away. So one electric field, write it like this. Okay? We have one electric field you will get this way. That is k lambda by r. Okay? K lambda by r. And one electric field you will get this way. K lambda by r. Done. Your resultant electric field root 2 times E. You can make the resultant here. Sir, what about the negative? How do we do that? The value is the same, brother. Angles in semi-infinite, electric field of negative. This way, this way, this way, this way, this way, this way, this way. It will be like this. So if you resolve all of them, one will come this way and one electric field will come this way. The value will stay the same because one angle is 0 and one angle is 90 degrees. So understand, we will get one electric field this way and one electric field this way. What will be the value of the parallel one? E parallel, that is, in the parallel we have k lambda by r, and E perpendicular, that is equal to k lambda by r. Did you understand this point? Sir, in parallel negative, brother, positive and negative, you have to think about direction. These are the values. Clear? Clear? Now I will how much time is left? One advanced question, okay? We have 5-6 minutes. I'll do one question and I'll give one or two to you, okay? Okay, use this. This question is in your Aerodove too. Fine, and after this I'll give you this question. This one. You guys can do this one. This one we have already done. I'll give you one for homework. This one we have already done. This is your Aerodove question. Okay? Sir, put mod in both. Yes, brother. Whatever angle will be there will be less than 90 degree. In the first quadrant, sign will never be negative. So I didn't put any mod. If you want to put it, you can. Go ahead. Okay? And there is a plus between the two. So now understand, you have to find the electric field here. Linear charge density is lambda. Linear charge density, that is equal to lambda. Done in gravitation, but still we will do it. Okay? Back then, see, when you guys were cursing me at that time, I knew that in class 12th, some would find it easy. Those who worked hard back then, they'll be feeling it easy right now. It feels familiar somewhere. And the new students, my boy, they are probably cursing me today. Some will go and leave me. That I don't know. All of a sudden, he goes somewhere else only. Some will leave. But those who stick around, I told you, for 3-4 chapters until I come to magnetism. Don't think of anything other than me. I told you that day as well. Don't think of anything other than me. And the whole day think about that only. Nothing extra. Not even 0.1. Because see, I'll be so enough for you that I'll eat up your brain. I'll put so much in you. And if you hold me up till magnetism. Because see, brother, physics needs brain, it needs patience. Okay, I told you earlier also, it's not a story that all of a sudden you'll start enjoying it. No. A twist came. No, you'll have to apply brain in physics. Okay? So all of these things, my way of teaching is such only. You'll feel like this is going, that is going. Then when those things start connecting, then you will have fun. Okay? So the high of physics builds slowly. Okay? Keep patience. Sir, we have to tell the electric field over here. Yes, electric field is a vector quantity. So brother, it's not like we will just add individual. We'll add directly. Some kids don't understand that. How do I do it? I said is electric field a vector quantity? Yes. So if I find individual electric fields, so can I find the resultant vector by adding them up? Yes, sir. So I said, tell me one thing. Is this wire with plus lambda visible to you? This wire. Yes, sir. It goes to infinity too, sir. I said, yes. So I said, man, because of this, over here at point O, can I write electric field like this? Sir, this looks like a semi-infinite wire to me. Look carefully. Sir, this looks like a semi-infinite wire to me. I said, yes. So, sir, positive's electric field will be away. So, over here and over here it will be. If you have thought this far, then I think you are doing well. Look at semi-infinite. For semi-infinite, it's k lambda by r, k lambda by r, k lambda by r. And for an infinite wire, it's 2k lambda by r. So, sir, how did you think of its direction? I said, just pick any one charged particle from here, put it here, and its electric field comes here. Its one component is this and one is this. That's it. K lambda by r and k lambda by r. It's done. Okay. I said, there is a wire over here also. Which one is this? Sir, this one is positive. I said, okay. So, if this is also going to infinity, will there be an electric field? And what will it be for semi-infinite? So it will come like this, k lambda by r and k lambda by r. I said very correct. This one And this one's electric field is gone. Yes. Now, sir, this is in the middle. It's like spinning in a circle here. So what happened, brother? Semicircular. Semicircular, we have a ring. The electric field of a semicircular ring, you already know, right? Electric field, you know already, right? It's positive. So what's the electric field of a positive? Now see, very small part matters, okay? Don't make it crooked. Sir, we used to make it in the angle bisector. I said, yes, here it is. Sir, it's positive. Positive. So the electric field will be away. I said, yes. And tell it in terms of lambda. The first one we found in terms of Q, sir. Electric field is KQ lambda by R. Sine of 180 by 2. So, sir, sine 90. This is 2K lambda by R, sir. Here you go, son. Now see. These two cancelled out with each other. These two are both in the downward direction. 2K lambda by R. Yes, sir. This and this cancelled out. E resultant, that is equal to 0. Who all have understood this? All students will tell. This is also a question in your Irodov. Solve it and come. And in the next class, brother, I say that if you have guts, then only come, okay? Otherwise, don't come. Advanced, Sunday class. Tomorrow we will talk about electric field intensity, about electric field lines. So come for that. Okay? Sunday, I told you, we will start thinking a bit differently. Then only you will be able to move higher, na? Slowly, slowly. Otherwise, you'll keep being where you were earlier. This is your Pathfinder question. Keep it for now. Try it if you want. Gravity we have taken as 0. It's a gravity-free space. Okay? And find the time period of oscillation. It's a good question. Today, I have taught you a lot of things. You will learn a lot too, but only if you would have an attitude of learning. Okay? The next JEE Advanced class on Sunday, I'm telling you in advance, complete revision, all the formulas on tips. If your background isn't clear, then you will struggle with every question. Man, where did this formula come from? What was x in this? What was theta in this? What was the direction of the electric field? F equals to QE, where? If you don't rise above these cheap doubts, if you don't revise, then the purpose is over. You go to good questions only when your formulas are on tips. Now, if your friends mock you by saying you're learning the formulas, okay, my dear, come here. Just throw 5 questions on his face and make him solve them. And I will also solve them. You have to learn the formulas. If somebody is feeding you this nonsense, then brother, don't memorize in maths either. Right. If you don't memorize the series of log 1 plus x, you can't do JEE advanced questions. For sure. So we have to memorize too. We have to represent things properly too. We will have to write properly for boards too. For advanced, we need critical thinking thought process too. Everything. It's a battle on every front. On every front. Okay? So don't get misguided. Whoever says anything, all the kids promise me, anybody says anything, we would not care about it. The day when I tell you, my son, go out now, you can do whatever you want, you can see whatever you want, that day you do it. Before that, first absorb it. Because if you start radiating already, you won't store energy. First absorb it. Yes? And in the class, there will be sufficient. Okay? I know I don't even need to say it again and again, but some students who are new, they don't have the confidence. Neither on them, and slowly he starts putting the blame on teacher only, that there's a problem here only. Okay? So what I want is that your mind should be clear. Okay? Now, today what do all students have to do after going back? Catalyst. Why I'm saying this, there is a reason for it. From Catalyst, my boy, Catalyst, my dear, I'm telling you beforehand, Catalyst will make you prepare for boards very well. You'll get to see the difference between the two. In Catalyst, till electric field, go and study once. Now study till electric field in it. And do I tell you the difference? Okay, I'll ask in tomorrow's class only. Those of you who will study, I'll ask tomorrow. This difference, those who will study it, they'll know. Okay, tell me tomorrow only. You guys only tell, then only others will know. Okay? Go and read, then only you will know the difference. And this difference only kids do not know. Come in the class tomorrow. Okay? Tomorrow I will ask once. Those kids who have it, you guys will tell the difference. Okay? What you have read about electric field so far, and that difference. And until you know that difference, you won't score marks in boards. Guaranteed. Guaranteed. Okay? So, we will meet in next class now. From here, there are very good advanced questions, my boy. Very, very good. So far, we haven't seen much of class 12th physics. We have only seen 2 topics, my boy. Just 2. And in the next advanced session on Sunday, we will only talk about all these things only. Then we will take another advanced session on Gauss law. Yes? I'm working something out on NCRT, okay? And that I will give you for free. The work I'm doing on NCRT, okay? I'll give it to you for free, alright? Okay? Yes, because there is no publisher involved, so there is no middleman. So it will be free for you. Yes? Yes. So I hope in today's class you all learned something. Some students must have learned a lot and some students must have left irritated also. I know. But this is the path, my boy. Believe me, this is the path. There's no other path for selection. No other path for selection. No shortcut, nothing. This is the plain, straight, minimum path. Minimum. If you think you'll take a shortcut, it'll only make the path longer. Nothing else. Stress, anxiety, all these things will also increase. The path will also get longer. You might even get lost. This is the shortest, minimum way I'm taking you from. If you think this is tough, then the other ways are even more tough. Having stress, anxiety, depression, which is comparatively lesser here. Okay? Love you all. Thank you so much to all the students who stayed till the end, who kept motivating till the end. Okay? And I wish you all learned something too. I hope it must have felt good. Those who learned anything with a positive attitude, please do let me know. I'll look at your lectures to see what we need to do in the tomorrow's class. In the next JEE Advanced session, what better questions to take. Okay? This is also decided by those comments and your responses only. Okay? So far, your response was good. So today I came up with some good things in mind to add and teach you guys. But the response of today's class is a bit haywire. But if you guys tell me, then in the next class, some good questions from Pathfinder, Supernova and all these can happen. Since we haven't covered many topics yet, so I'll take some good questions from Supernova, Pathfinder, Aerodove, Tata McGraw-Hills. Okay? Yes. Love you all. So we will meet in the next class. Okay? Please do tell this, my boy. If I say, people will think man sir is saying something else. You guys will tell me now, okay? Those who have it, read till electric field lines. Electric field lines you haven't read, right? Read till that, okay? Then tell me what is the difference, okay? We'll meet in the next class. Till then, tada, bye-bye. Keep studying and keep enjoying.